Good job, everyone. You have completed up to section 1 and section 2. Now, this section, I'm going to start section number 3. In section number 3, we have to learn a lot. We have to learn about Cisco platform and development. You can see the weightage is 15%, but the content is quite large. You can see that you have to understand constructing Python script using SDK documents, describe the capabilities of different type of Cisco networking management platforms, such as Meraki, DNA, ACI, SD-WAN, NSO, means all of Cisco products related to network management and orchestration. Then understanding the compute management platforms such as UCS, Intersite. Then Cisco has their collaboration product like WebEx, Unified Communication Systems. Then Cisco has security product. Then understand the APIs, their features within iOS, XE, and XOS, then understanding of the Yang, RESTconf, model language, then construct code related to that, construct the code or give the lab examples related to different orchestration planes, and then finally 3.9. You can see 3.9. In 3.9 we have A, B, and C. So that means we have the lab related to all the sections in section number 3. That is the orchestration platform, that is the collaboration platform, that is with a Meraki, right? So you can see the topics are huge, and one by one we'll go and work on these topics. So why not? Let's go and check 3.1, where we have to understand about constructing the script with software development kit, SDK. We know that Cisco has their own management and orchestration plane. For all those management and orchestration plane, Cisco has their own software development kit that you can go to their sites and you can install. You can go to their site, you can read about this, and you can install in your laptop. In your Python package, you can see that we can go and install the Python package as pip install DNA Center SDK. For example, this is DNA related software development kit. You can install it. Now, if you go to these URLs, you will see that they will tell you that these APIs can do authentication, client related information, network related information, configuration related information, means all those informations they have that you can go and install those as a kit within your system, within your workstation, and then you can run those scripts, and we have to build, and I have to show you one example related to how we can use this document. So this is the document, you can go and have a look on that. I'm going to use this document and want to create one of the script. So here you can see that I'm using DNA Center SDK. I have installed in my laptop, and I'm going to use Cisco DNA Open sandbox URL that you have seen in the previous section, last 2-3 videos. That's the same URL and password I will use. So let me show you that in my script I'm using this sandboxdna.com. This is the username, this is the password. I'm going to use this script. You can see this script importing the request and importing the packages DNA Center API. So from DNS Center SDK, we are importing, in this script, we are importing DNS Center API. And with this DNS Center API, you can see, again, I'm storing DNAC. Within DNAC, I'm storing the username, the password, the base URL, and the certificate verification is false. Verify is false means if you are getting any certificate error, that just ignore it. Then what I want from this script, that I want to print the device list. So obviously with the output, you will get complete JSON format. You will get big JSON format. And with that JSON format, we want to print only host name and the management IP address. Let me show you that script in my Visual Studio. You should install this in your laptop as well. You can see this script that we are constructing the script, Python script with the SDK, with help of SDK. So these are the import package statements. Then I'm storing the credential, DNA, username, password, URL, certificate verification false in within the DNA. Now what is happening here, if I Simply select DNA. You can see that devices equals to DNA dot. Dot means that the concatenation, you know, that dot means that this function and then this function. Now if you go and check the SDK, that particular URL, you will see that device get device list. Actually this is get device list is one of the API call. In that API call, it will go and get all the device information. Now, all these device informations, they are part of devices. So one folder is devices. Within that folder, you may have so many different options related to getting the device list, getting the MAC address, getting the device ID, getting this, like 15 to 20 different devices related information in that API. So devices dot get device list will give you, will go under devices and will give you the device list information that is again part of DNAC. So this we are storing this API information. Actually, this is the URL information to log into the URL, because all the APIs, because these are the HTTP methods, these are the RESTful APIs. So your API will start after this URL slash some devices slash some API. So that means we have the information up to DNAC. Then we are going, DNAC means the URL and password. Then we are going inside the devices. Then we are going inside the device list. And then all those information we are collecting. Where we are collecting? Those informations we are collecting within the devices. Those information will be collected within this devices, right? This place here. Now, once you have all those information collected within devices, then you are running one for loop. In this for loop, suppose if I have 10 devices, so this for loop, what it will do, it will go and run for 10 times, but all the time it will go and print the host name and the management IP address. Host name and the management IP address. How long it will print? Till that device will end. Till that, suppose if you have 5 devices, this loop will print for 5 times. 10 devices, this loop will get printed for 10 times. So we are putting this input, devices input, device list input in a condition that is devices and the response, devices in the response that I want the output. And then for loop is going on till how long? Till that you will get the list of the devices. So let me go and run this. Let me show you this in action. This is enter 3. So this is my program name. If I go and run this, you'll see it will go and contact this open sandbox. Once it will go and contact this open sandbox, it will go and use DNAC device get API within the devices. Now these devices will be a big output. So if I go and print devices here, let me show you that as well. So that will be a big output that you will see. It has all the information. You can see all the informations it has. It's a big output, but from this big output, right? It is in JSON format. From this big output, I have chosen only 2 things. What are those things? I am choosing only the host name and the host name and the management address. But suppose if I want to add one more, for example, I want to add device and then I want to add the serial number, right? So if I go and run this command, because you know the JSON format, they have the key and value pair. So now you will see that in that output, we not only we have the switch and the IP address, we have the serial number information as well. So how I choose that? Because JSONs, they are giving the key and value pair. So if we have some key, if you go and put that key here, it will go and print the associated value. So managed is true, memory size not applicable, tunnel, like all the important information. So for example, host name we have printed, management IP we have printed. If I can go and print the platform ID, so this also I can go and add here. Again, I can go to the device and then I can go to the platform ID, and this time if you go and run this script, it will tell you the host name, the management IP, the serial number, and the platform ID. So like that, you can go and filter your output. Right. So you can see that with help of Open SDK, with help of software development kit, we can go and create our script. And now you know the part one, part two, part three, is where is the request, where is the header, where is the authentication, where is the body, and how we are utilizing this script. This part is the Python intelligence, where you are putting some loop, and with that loop you are getting the result. So although you are getting the JSON output, but that is the dump, like this is JSON dump. From this JSON dump, with help of Python tweaks, you are getting the output in the formatted manner, in the desired manner that you want to see. All right, so I hope that you understood this example. Let's stop this video. In 3.2, we have to understand Cisco networking devices capabilities. Means Cisco, they are offering large number of network management and orchestration platform such as Cisco Meraki, Cisco DNA, SD-WAN, NSO. For data center, they have Cisco ACI. Like for different unit. So for SD-WAN, we have Meraki and Cisco SD-WAN. We manage. That's the controller name. For data center, Cisco has Cisco ACI, application centric infra solution. For fabric, campus LAN fabric, more precisely, or software defined accesses, they have Cisco DNA center solution. And for heterogeneous network, they have NSO. Like that, different platform or wide range of platforms are there for different places, for different networking types, you can say. You can manage and orchestrate entire fabric from these management plane or orchestration plane. Now, the good thing here is this, that if someone has good knowledge of Python, and if someone has good knowledge of APIs, so they can go and integrate Python and API. So learning Python is one-time effort. Learning APIs is also one-time effort. But you can go and utilize all these efforts in these 5 to 6 different places. So then you don't have to go and learn each and every task related to how you can go and manage the things from Meraki dashboard, from Meraki cloud dashboard. Meraki is a solution. They are offering SD-WAN solution. They are offering LAN, firewall, IPS, switches, routers, and IP cameras. Like it's full-fledged solution. It's a successful solution. So many companies, they are using Meraki. But suppose if you have to go and manage n number of sites, so you will not go to the each individual dashboard for each individual site and manage this. If you have good knowledge of Python API, you can write some script, and with that script will work for you. Same is true for Cisco DNA as well. From Cisco DNA, you can go and manage the entire LAN fabric. Entire LAN fabric, even if you are not using DNA as a SDA, still you can do so many operational tasks such as image management, plug and play, compliance management, etc. Like, the use cases are huge. Again, coming to ACI, ACI is purely data center solution. From ACI dashboard, from that dashboard, you can go and manage the complete data center. You can go and create the tenants, the VRFs, BD, application group, EPG. These are the terms within ACI. Not only the physical infra, the virtual infra also you can manage. You can create task, I mean, you can create a script that will go and perform certain tasks. So you can manage the entire data center fabric from ACI, from your Python plus API knowledge. The same is true with Cisco SD-WAN as well. You can manage the entire SD-WAN devices, their onboarding, their upgradation, their compliance, management, security. You can see the list is long. You can see here in the below, the list is long. All those things you can go and manage from the Cisco SD-WAN, that is the vManage dashboard. Right. And last thing here in this agenda is the NSO. NSO is the orchestration platform for heterogeneous network environment. From NSO, again, with the integration of the Python and API, you can go and manage the entire heterogeneous network from that uh, dashboard, from that orchestration plane. Obviously, you have some GUI where you can log in and manage the everything. managing from GUI to all these areas will be little bit difficult, but you can manage. If you can manage this from APIs, then it will be easier for someone to manage, because you can develop the API script. Once API is already there, you can develop the script, and from that script you can manage the infra. Now, I have added few examples for all those management plane. So, for example, Meraki, how you can go and integrate Meraki API with Python. You can see that is the same. You can see the structure is same. So you have the import packages, then you have the keys. You have to go and define the header. You have to go and define the APIs. This is the API where you are calling the organization ID as a variable. Then you go and collect the responses, and then you can go and print it. Likewise, we have done in our previous section, that was for DNA, Cisco DNA, right? This is for Cisco Meraki. Now you can see there is like 95% things are matching if we are comparing this with the DNA. In DNA also we are calling some package, some SDKs, then is storing in DNA, then is storing the response within DNA devices, get device list, and then we are printing it, right? So very much like 95% they are same, because here we have to know about the APIs, and we have to know about the API integration with Python. Now coming to ACI is again, data center is different ball game. Before even creating the script, you should know that what is the meaning of TNet, what is VRF for context, what is bridge domain, subnet, uh, what is meaning of application profile, and all those things, and how they are glued together. So if you have the basic understanding about the terminologies, about the specifications within the data center managed by ACI, then you can go and easily write the script, because in the script what you have the username and password. Obviously you will store all these information within some session login. So you are logged in. If you are logged in successful, if your username and password obviously correct, your URL is correct, your logged in will be successful. So once you logged in, then what you want to do, you want to create tenant, you want to create VRF, you want to create BD, you want to attach the VRF to the BD, bridge domain. BD is bridge domain. They are the gateways. So you want to attach gateways with some VRF. You want to add some subnet to the VRF. All those things you can do via the scripting, via the Python and the API integrations. Those things are possible. Although there are different flavors are there. For example, ACI we are using Terraform. Terraform is again one programming language which is very lightweight and easy to understand, and its implementation is also very easy. Or you can manage from your Python knowledge as well. Likewise, if we are checking the SD-WAN integration, again, this is also very much similar, that you have to define the URL, the header, the API, and then you can print the API. So if you go and divide this in a step 1, 2, 3, 4, it's almost same. See, SD-WAN and this DNA, or maybe SD-WAN and Meraki, how similar they are. Even the last few lines are almost same. The last few lines are almost same in the SD-WAN as well. And the import packages and the variables that you can go and log into the device. So those are also same. The last example in this list is NSO. Again, you are importing the package same way. You're defining a username, password, and the URL. You're storing that session within the NSO. Then if you have any service related to firewall, you can define that service. This is my new service. Again, we are using some sort of JSON payload, right? This is the payload in JSON format. Key value. So name, new service type, firewall, source, client, destination, client to protocol, TCP, some sort of ACL entry we are creating from source to destination for protocol, TCP port 80. Like that, you can go and add more and more information here. And then finally, once you have all this information, you can go to the response. This is just the variable name. You can go and put all these information. So what we are doing from NSO, we are creating the service, that service data is this is the payload you are putting inside the services within the NSO, and then you can implement it, right? And then if you want, you can print the output as well. So you can see either it's any type of service, they are almost the same, even 95, 96% they are the same. So that's the usability we have, that learns once and utilize many times. That's the power we have with the programming and API integration. In 3.3, we have to understand about the compute and data center cloud platform and their integrations with the Python script. We have two examples here. We have UCS Manager, which is basically the used in data center as a server virtualization management tool. You can think like that. And then we have Intersight. Intersight is used as a cloud automation platform within the data center. So let's understand both one by one. Let's check the UCS Manager. UCS Manager is the management plane for server virtualizations in data center. And you can see that with UCS Manager, we can do hardware management. Service profile means you can create such templates with help of UCS Manager, and that template can be used or consumed by n number of servers. Then we have policy-based management, integration with virtualization platforms, and it is aware of RESTful APIs. That means that the UCS manager can be integrated with APIs because it can understand APIs. So with the help of APIs and Python programming, we can integrate uh, this with UCS Manager, and with that feature, we can manage the hardware management. We can create the service profile. We can create the policy, or we can do the policy-based management. We can go and manage the virtual environments as well. So before moving further to Intersight, let me quickly show you one example related to UCS Manager API. Here you can see that as all other APIs examples, you can go and define the IP and the password and the username. So you can log into the device, right? Then we can go and check the number of servers, how many servers you have, and then you can create the service profile. Service profile is nothing, but you can create some sort of template related to policy, boot policy, local disk policy, VNIC policy, etc. And these policies related to server. Obviously, a server having what type of attribute? Server having booting policy, server having interfaces, that is the NIC, either NIC, VNIC or VHVS for storage, server having some other policies. Means all those policies you can create a small template that will be glued in the service profile template, and that template you can go and attach with the server. So if you go decommission the server, your server will get decommissioned, but your template will be there, your service profile will be there, that later on again you can reuse this service profile to other servers. Right. So what you can do here, that you can create the service profile and then you can apply the template to the server, and then you can log out. So you can see that very a small program, maybe 20 lines program is there, that will go, and that you can go and create, and it will be utilized to create the service profile and then apply the template to the servers. Right, let's go back and understand the Intersight. Intersight, you can see this is the cloud-based management. With Intersight management, you can have the unified management for different type of server, storage, and networking components on-prem or over the cloud. The good thing about Intersight that they are policy driven. They can understand AI and analytic tools, and you can integrate with CI/CD pipelines. Right? They can understand the RESTful, and they have the software development kit. Since this is cloud platform, obviously this is software that you can install anywhere. Now this particular Intersight software will be used to manage your data center infra within the premises, like it's your physical or your virtualization system. Means point here is this: on-prem and cloud. So both places your workloads you can manage with the Intersite. Now, since it is API aware, since Intersite is API aware and it has its own software development kit, you can go and write the script integrating API with Python script. So here you can see that same thing. Part one, that we can go and log into the device. Then we can go and get the list of the compute devices, servers in Intersite. So you can go and get that list. Once you have the list of the compute devices or the server in the network, then you can go and have the policy, means you can go and create the policy. Once you create this policy, then next you can go and apply this policy to the compute services. The same way we have checked this thing in UCS as well. We are logging to the UCS manager, creating the service profile template, and then applying or attaching this template to the server. Here also in the Intersite, you can see that login to the devices, and we know all those ABC of this thing. We have discussed a lot about the headers, the body, the authentication, these parts in our previous discussions, in our previous sessions. So you can log into the device, check number of compute resources, create the policy, create the new policy, and then that policy you can go and apply to the compute servers. Right, so you can see the usability here. Usability is big, that not only the network management platforms, but the computer resources, compute resource management platforms also you can manage with respect to API and the script integrations. As we are exploring on Cisco platforms which are API aware, in this line, next topic we have Cisco collaboration, Cisco voice solution platforms. Here you can see that Cisco collaboration platforms, we have WebEx. WebEx is one of the popular collaboration tools we have. Even we can install in our laptop, in our workstation for free. Even we can use it for free as well. It's like very much similar like Zoom or other meetings, but it has so many nice capabilities, and Cisco has enhanced WebEx devices in a way that it can be API aware as well. WebEx and these tools you can integrate with other third-party management tools or even Cisco tools as well. For example, Cisco DNA, I can go and integrate with WebEx, Microsoft Teams, and other messaging systems, messagings and collaboration tools as well. So we have WebEx devices, we have Cisco Unified Communication Manager. In short, this is CUCM, that is included with the administrative XML APIs and UDS interfaces. So CUCM, again, it's a unified communication manager, and it has API integration. It is aware understanding of APIs. Now let me walk you through one by one, step by step. So you can see here that we have WebEx, starting with WebEx, then WebEx devices and CUCM. Let's check few important points related to these appliances, these services. WebEx, as I told you that WebEx you can go and install in your laptop as well, and it is there to provide you services such as messaging, video conferencing, voice call, file sharing, and online meeting. It can be integrated with some other third-party tools as well. Formerly, it was known as Cisco Spark. Now it is retermed, or the new name is WebEx, and it's quite popular. WebEx meetings for virtual meetings, WebEx calling, cloud-based video service. It has services like, again, if you are using Zoom for meeting, it's very much similar. Like we have this WebEx for Cisco solution. Even you can compare this with Microsoft Teams and WebEx. That is the good comparison. Microsoft Teams also having same type of capabilities, and Cisco WebEx also having these type of capabilities. Plus minus, we can see that who is much more API aware. As you know that Microsoft is also in the software field. Cisco was in hardware field. Now it is moving to software subscriptions, and now they have so many SDN controllers, so many controllers that people can subscribe as a software as well. Then Webex has API for integration. Yes, it has the API integration. You can use Webex API keys and Webex Room ID to integrate with Cisco DNA or any other third-party tools. And it has developer resources. Developer resources means that it has resources related to software development kit that we have discussed earlier. And we created some lab example related to DNAC SDK. Likewise, Webex also has SDK, and where you can go and learn different type of APIs and their uses. Next in the line, we have Webex devices. Webex devices, these are the hardware. These are the endpoints. So you can see that we have the collaboration endpoint, that is Cisco Webex device included for, from those devices, from those endpoints, you can go and do video conferencing. It has room kits, desk devices, collaboration display devices. These are basically consumed in the offices or in the organizations, in the corporates, in the enterprises. They have good amount of endpoint devices that you can manage from some manager like CUCM. So what you can do, these are the endpoints. You can create configuration profile and dial plan, all those things, and push to these endpoint devices. Yes, they have the intelligent feature. These devices are equipped with intelligent features such as facial recognition, voice commands, whiteboarding, content sharing, and integration with the cloud services like Office 365 and other Google workspace, right? Now, since we are moving to the software world, so all these devices, so either it's a WebEx or WebEx devices, they are API aware. So that means you don't need that a CLI configuration, or go and log into individual devices and do configuration one by one. Since they are API aware, so we can go and do all such type of operations related to configuration, creating interactive application, integrate with business processing and applications, and other advanced features we can integrate within the WebEx devices. Final in this collaboration, as per our curriculum, is the CUCM. That is, you can think as a herd of the communication system that we have in the Cisco portfolio. A CUCM is a call, control, and telephony management solution that provide call routing, signaling, call handling, media processing for IP telephony. Now, this is something, and for CUCM related uh, area, for CUCM related knowledge base, we have separate CCNP course as a CCNP collaboration, as a CCIE in collaboration. So you can understand that these technologies are itself, something that you have to go and learn, understand what is call handling, what does mean by call routing, what is signaling, media processing. All these are technologies, and it is well defined in the CCNP collaboration or CCI collaboration. So if you go and learn those those areas, those things, then you will understand in detail about how the dial plan is working, the call signaling is working, call routing is working. You know, so there is technology behind this. Then you can see that CUCM also coming with the API integration. We have AXL, administrative XML layer, that will go and enable the administrative tasks such as management, device configuration, dial plan configuration, call operations via the API, via the XML based API integration, right? Again, in other terms, via the programming. Then finally, in this, we have UDS, User Data Service API, right? So User Data Service API will allow users data and profile information is stored in CUCM, facilitate integration with the directory services. Again, this directory services is also one technology that you can learn, and they are using the wildcard characters. While doing such type of configuration, you can go and use that wildcard characters to create such type of profiles and the services. CRM system and identity management profile. So it's something like user data service, but since this is API aware, so you can go and manage things via the API. So you can see now clearly in CUCM itself, we have administrative XML API layer, and we have UDS, user data service API. So these features, these advanced programming capabilities makes CUCM easy to use. If someone knows this API and how to integrate with these APIs and how to utilize these APIs, then it will be easy to manage n number of endpoints via the CUCM. Now, next in this line, what I have done is just to show you one of the lab example. I have one lab example here. That lab example, what this lab example will do, that we'll go and create one room ID and we'll send the message. That's the goal of this WebEx related API related example. So as all the programs that they are starting with importing some packages, so import request and the JSON, then you have WebEx API URL and access token. These tokens you will get. Obviously, you have WebEx API URL, and then you will get a a unique token that you can go and put here. Now, how to create? So you can see the function defining here, function to send a message in WebEx team. And then next function we'll see that how to create the room ID. So here you can see room. How to create a room is defined within a function. And here you can see that how to send message defined within a function, right? So this is one of the function where we are defining the headers, we are defining the payload, headers and payload. In the payload, we have room ID and message, right? And now if this function is successful, so here you can see that this is my post method. This is the HTTP method. And these things we have learned a lot. If you are following my videos in sequence, and if you know that earlier videos, then you know this thing, that we are using post method. Why? Because we have some payload. So this post method we are using here in the API, that we want to post this message to this room ID, and if this is successful, it will print successful message. Otherwise, it will throw error, failure message. Otherwise, it will print failure message. This is not successful. So here you can see that now we know the import packages, the headers, and how to define a function. So within a function, we have the headers for authorization and content. Then we have the payload. Then we are using the API with conditions, success and failure. Likewise, we'll go and create a room. So here also we are defining the header, we are defining the payload, and then we have the API. So within that API, we are using the post method Y, because we are creating the room with the payload. So this is my API to create the room. So with this function, I am creating the room. If it is successful, then print successful message. Otherwise, it will print a message that failed to create a room. Then since we have two function send message and we have function create the room, then I am calling everything within the main function. This is my main function. In my main function, my new room ID is create room. See, create room. That means I am calling this function within the main function, right? Create room. We are calling this. So what this will do, this will go and create the new room. So new room, what is the payload we are putting? We are putting the payload as a test room. And what is the message we are putting? Message we are putting hello from Python using the WebEx Team API. So we are creating this room and we are putting this message. How this message will get put? From this function. Where is this function? This function is here. So in the main function, we are putting one condition that, oh, main function, create a room. And if you have the room, send this message, right? So you can see that with the API feature within the WebEx, we can go and create such type of program. Great job. You have completed up to 3.4. In 3.5, we are continuing the Cisco portfolio, right? So in Cisco portfolio, we have a study about networking management or orchestration plane or orchestration devices such as SD-WAN, DNA, ACI, NSO, etc. Then we check the collaboration, Cisco Unified collaboration or Cisco collaboration products like WebEx devices, and CUCM, etc. Now, all these devices, you can see that they are API aware, right? They having the capability related to API. Then we have checked the compute management platforms as well, like UCS Manager, like Intersight. Now, in this 3.5, we have to discuss about Cisco Security Portfolio. Cisco Security Portfolio, you can see that we have the list that we have XDR, Firepower, Umbrella, Cisco Umbrella, Secure Endpoint, ICE, Secure Malware Analytic or Analysis. Now these products, so Cisco is there in security domain as well. Cisco has their security product for cyber security, for to provide security in data center, in branches. They have their own identity services such as ICE. They have their own next generation firewall, malware protection. You know, long list of security products Cisco has. As per this curriculum, let's understand this one by one. A secure endpoint. Here you can see secure endpoint in this portfolio, in this list. Let's start with secure endpoint. A secure endpoint, formerly it is famous, popular as AMP, Advanced Malware Protection. That was the name. Now it is secure endpoint. Now what this secure endpoint will do, obviously it is for malware protection. So it will go and protect from malwares, right? So different type of file analysis it will do, and it will detect in those files if you have some script, malware script. So it can detect, it can raise alarm, and all those actions it will take. It is using sandboxing technique as well. Sandboxing technique, that means that you have some cloud hosted um, malware protection. Uh, it is something like that your appliances, they are connected, or they have connectors or open APIs to cloud. So suppose if you have to go and analyze 2 gig of data, or maybe 50 gig of data, your firewall will not allow that 50 gig to go within the network and then do the inspection, right? So what it is doing, that it is downloading few bytes and then it is redirecting that entire 50 gig of data to some cloud where it can do some sandboxing, and then it will analyze that packet and the performance of that download and all the files and bit bytes within that, and then it can raise the alarm. That is the overall concept we have with the secure endpoint or Cisco AMP. Now yes, it is API aware, so it has the APIs that can do the orchestration, automation, and this SOAR is very important. This SOAR is nothing but security, orchestration, security orchestration, automation, and response, SOAR. Yes, you can go and integrate with SIEM devices. There are so many SIEM devices. Cisco recently has acquired one of the company uh, for SIEM, and there are so many others as well in the market to do some third party integration. So APIs are there to do some third party integration, and they can go and do the threat intelligence sharing and endpoint management. We know APIs are there to do certain tasks. So you can send that information to maybe some third party platform to do some more analysis with API. Obviously, API will work as a integrator, as an interface, open interface to integrate with third party tools to do some more analysis. Next in the line is Cisco Umbrella. Now, these topics are big. Even you can find 400, 500 pages book on these topics. These are huge. For example, Cisco Umbrella, Cisco Identity, Cisco Umbrella, yeah, not Identity Service, Cisco Umbrella. Cisco Umbrella, it is something like open DNS security. It is something like providing DNS label security. But you can compare Umbrella with some other cloud security providers such as Zscaler or iBoss or any other. So that means that Umbrella will provide you some perimeter security over the perimeter when anything is coming from public cloud hitting your premises, either data center or branch or any other HQs. Then Umbrella will go and provide you DNS level security. Not it is providing DNS level security. Now it can provide you firewall level or URL filtering level solution, web gateway solution. In SD-WAN devices can be integrated with Cisco Umbrella, and Umbrella can work as a gateway while your guest user wants to access internet. So gateway will be Cisco Umbrella. There they can go and filter the content, filter the URLs, filter the firewall rules will be there. It is working as a gateway. So it's a big product. Cisco Umbrella is big product, and it can provide you DNS security, but there are so many features such as Zscalers and other cloud security provider gateways, right? Now, Umbrella also can be integrated with API, and once you go and integrate with API, then from one place you can manage the policy, reporting, event notification. You can do some configuration as well, like automated security workflows, integrate Umbrella with any other third-party tools as well. So those options are there, right? Next in the line, we have Cisco Firewall. Flat, this is next generation firewall that can do everything. Next generation, because it has the next generation capability. So it can do AMP, advanced malware protection, URL filtering, IPS protection, right? And even it can be integrated with sandboxes, threat gateways to provide some more security. It is, yes, API aware, all those next generation firewalls. Cisco having Cisco Firepower as a device, and FMC, Firepower Manager, as a management plane from where, so that FMC will be API aware, the FTDs are API aware, so that you can manage your workflow, manage the task from one place, and manage the activity from firewall with respect to APIs, right? Next, ICE, Cisco ICE. Cisco ICE is also one of the successful product from Cisco. This is something related to identity services, irrespective of wired, wireless, VPN, phones. It can do the authentication for everything, right? It can do the authentication and authorization for everything. It will provide you full solution, full end-to-end solution. It is a very nice identity service platform provided by Cisco. It has both the format, virtual and hardware. It has both the form factors. Next in the line, we have secure malware analytic. Formerly, it is known as Threat Grid. Now, what it will do? Obviously, it will go and do the analysis related to malware. It is using the malware. It is using the malware sandboxing technique. I told you earlier that you can go and integrate this with SD-WAN vManage. So SD-WAN vManage will go and it will not allow the devices to download the full data, although it will go and redirect the gigs of data to the sandbox. And SD-WAN vManage is just the management plane. Actually, the actual intelligence is there in the edge devices. So edge devices. So the formation of fabric is in a way that your edge devices, your routers, which is working as a next generation firewall as well, it will get some direction. A policy will be like that you can go and create from vmanage and push to the devices. It is in a way that the devices actually in the data path, the devices will send that gigs of files to the threat grid, to the gateways, to the threat grid gateways or secure malware analytic gateways, so they can analyze the data and give you the result. Now this is also API aware. Why? Because if you want to integrate your vmanage, right, your vmanage with threat grid or secure malware analytics, you need APIs. So any third party integration will be happen with the APIs only. So obviously you need APIs. So APIs are there for threat intelligence, sharing, malware analysis, and automated threat response. This is one of the key that you will see again and again. So not only that with API, you are getting the notifications that this is happening, this is wrong happening, this is bad happening. But these devices with APIs can do the automated response as well. Something is happening, your program is in a way, something is happening, take this action, something is happening, take this action. I'm going to show you this example in the next. Next in the line, we have Secure X threat response. X stands for extended. So we have extended detection and response system. This is a response system that correlates security alerts, events, and telemetry data from multiple security product and sources to provide comprehensive visibility related to threat intelligence. Right. So it's something like you are sending amounts of information from different security products, and you have one intelligent engine somewhere which is correlating these events, these alerts and telemetry, and then it will provide you some response. Like, so some threat is happening, this is the response. Now how this is this much intelligent? Because the XDRs, they are API aware. So we have APIs for orchestration, and since they are API aware, then they can take the input, so alerts, events, and telemetry data as a input, correlate it, and with some API, it can provide you the result, right? So now you can see long list of the security engines that we have in the Cisco platform: XDR, Firepower, Umbrella, that is the next generation firewall, Umbrella, Secure Endpoint, ICE, and Secure Malware Analytic, right? And with help of these security tools, you will feel good. These security tools, it will provide you security in the framework. So let's see some of the API examples. So we have one example related to secure endpoint. With this small example, you will see here in this example that will take action based on the severity of event. So high level severity, low level severity, mid level severity, what action it will take. So let's see. Now again, I told you earlier that again, the things means that the header, the URLs, the API, the function calling, those will be same either irrespective of compute platform, network platform, any platform, right? Collaboration platform, any platform, they are the same. So here you can see you can import some packages, then you can define the URLs and the tokens, then you can define the function. What is my function? Get security events. I am defining the headers and the parameters. In that, event type is threat, a start time is this, and I will go and take 10 events. Now you can see the response here. So in the response, what we are putting, that response request get, this is your API, get what you want to get, endpoint API URL and the parameters. So if you have the parameters, means you have the endpoint, and the event is what? Threat. What is the time? This. What is the limit? 10. Okay. So if you are getting some event notification, then successful. Otherwise, fail to retrieve the security events. Now, once you get this event, so once I get the event, I'll go to the main function, events equal to get security event, get security event. In the main function, I'm calling the sub function, get security events. If events, in events having severity high, then high severity event take action. If severity is medium, then notify the security team. If severity, or else, then if severity is not medium, then logging for monitoring. Right, so you can see the logic, the programming logic. Where is the API use here? API used just to get the information, right? That this is the event and this is the threat and this is the high level, then I will take action. Otherwise, I will notify the security team, or otherwise I will log in for the monitoring. Right. So now you can see the intelligence here, that we have the intelligence with the API and the programming logic. If you add both of the things, your system will become intelligent. Now let's go and take one example related to Cisco Umbrella. Based on the threat intelligence, I want to block certain domain, because I told you earlier that it can go and block domain, it can do some firewalling, it can do some uh, it is like full-fledged gateway device. So firewalling, URL filtering, some intelligence related to blocking some content, those features we have in Umbrella. So here also importing the package, defining the URL, same thing, right? Then define one function, block malicious domain. and the function parameter is domain. Then you have the header, and then you have the payload. What is there in the payload? Payload is data. Within data domain, action is block. So we are defining that if this is the domain, block it. If this is the domain, I am calling this function, and if I am calling this function, block it, right? So now you can see that response means call that API with the header if this is successful. So this is my function. This is my full-fledged function. If my API call is successful, this function will get executed. Now come to the main function. So in main function, malicious domain. Suppose this is the malicious domain, right? Malicious domain. This will be my input here. At the moment, I will get this input, for example, some poker.com, some abc blockit.com, some xyz.com, some social sites.com. Those sites, if you go and define here, and if it is a parameter within the function, if it is a parameter, then what this function will do? That will go and block it. Why? Because we are defining in the payload that if the malicious.com will come, action is block, right? So you are calling the API. See, everything is the same. Whatever we have studied, everything is the same. And then with this API, you can go and block this. You can go and block this. All right. So that's this section. It may be a little bit lengthy. Let's just stop here. Good job. You have completed up to section 3.5. In 3.6, we have to understand about API features within iOS XE, Cisco iOS XE, and NX Nexus operating system. What about the dynamic interfaces within these operating system? So let's try to understand this, and then I will show you one lab example as well. Now, when we are talking about iOS XE can go and support RESTconf. RESTconf is nothing but HTTP type of method that is supporting different type of methods to get the information, to create an object, to update object, and the delete object, like get, post, put, and delete methods. Apart from that, it is supporting the netconf protocol. They are using port number 830, and this is XML based messaging, means it is using XML based data format to configure and monitor the devices. Now, if I give you an example related to netconf, the classical example for netconf is Cisco SD-WAN. Within Cisco SD-WAN, from vManage, you can go and push the configuration to the devices, to the edge devices via the netconf protocol. So it will be like this. With the netconf protocol from SD-WAN vManage, that is the management protocol, that is the management server or management plane. From vManage, we can configure the devices with netconf, which is using port number 830, to different type of edge devices. Not only vManage, all the devices that we are configuring from vManage, either it's other control plane devices, they are using netconf port number 830. So that's the example related to netconf. Then it is supporting a well-formatted YANG module. These are the data models that is also supported. So this type of data structure is supported within the iOS XE. So RESTconf, netconf, YANG model, everything is supported within iOS XE. Then it has the dynamic interfaces that you can go and create EEM, embedded event manager scripts. And those scripts are something that once you go and create these scripts, and suppose if you go and connect these scripts with the guest cell. Guest cell is something that within the box itself, you can go and create the Linux type of environment. So suppose if you go and create the EEM script, first of all, EEM script itself, they are powerful, and that will be used. If any event will get triggered, it will go and take action. So that will allow you to monitor events and take automated policy based predefined policy response, that if shutdown event is coming, do this action, run this CLI commands, etc., etc. Right? So even you can go one step further with EM script, that you can go and connect that EM script with a Python script, but for that you have to go and create some sort of guest cell within the operating system itself. But it is possible that EM script is one of the independent feature we have within the iOS XE devices that can be connected with a Python script, and even you can make your automation little bit more robust. Next, we have Nexus operating system. Nexus operating system, first of all, you can go and enable the NX API feature. This will provide you RESTful API feature that is supporting both XML and JSON format. So even iOS XE also we have the RESTCon feature, but not the NX API. But within the Nexus operating system, you can go and enable the NX API feature. It is supporting netconf that we have just now discussed. But NX OS operating systems, they have NX SDK as well, software development kit as well. And we know about this software development kit that it has all the methods, it has all the packages, it has all the APIs that is built within the package itself. So what you need to do, simply call that particular SDK, and within that SDK you can call any type of API. Right. And we have seen this example related to one of the DNA example earlier in this section. So how this SDK is working at this point of time, even you can go and install these SDK in your Python packages as well. Right. So it can go and call certain methods within the program. In terms of dynamic interfaces, yes, NXOS, they are fully supporting automation, and they have this feature called power on auto provisioning, POAP. This is very popular term, POAP, power on auto provisioning. Means at the moment you will go and power on the device, it will get the initial bootstrap configuration and some sort of software install. Right, so POAP is something like you can think as a ZTP, zero touch provisioning, that these devices have. It will go and bring up the device with zero effort, minimum effort, right? Then obviously you can go and integrate the SDK with a Python. You can write your code in a Python, and in Python package you can go and call the SDK, and within the SDK you can go and call different type of get, put, post, those type of methods, because Python uh, because NSXT supporting SDK which can be integrated with Python, and we know that SDK, they are fully supporting the REST APIs. So that means all those features are on get, post, put and delete methods, right? So at this point of time, you can understand that, okay, iOS XE and NX OS, they are fully supported via the automation features, automation protocols. Now let's go and write one program and check this in the lab setup, that we have one program where we want to get the interface information of certain interface, right? And how we can go and execute this program. So here you can see in all our programs, that we are importing certain packages, then the device URL, IP, etc. means the device information, then RESTconf URL. With this URL, this is nothing but RESTconf API, because RESTconf is itself API type of feature that will go and use methods, right? That will go and use methods like, here you can see get method means get some information, like show commands in Cisco operating systems. So in this URL or in this API style, what we want the data interface name. So we want one of the interface, suppose 0/0, gigabit Ethernet 0/0. For this interface, I want the full data, full information. So then I can define the URL, then I can define the header. These things we have already discussed in our previous section. This is this is the format which is fixed almost in all devices, all management devices, right? This is the style, this is the method that is common everywhere. Then you are taking the response. So response I am putting here. Once I have the response, then what I can do? Then once I have the response, again, the same thing I mentioned here, because this is in below. So here you can see that once you have the response, then you can check If you have success code 200, that means successful. We know about these codings like 200, 400, 500. 200 means successful. Otherwise, it will go print error, that you are unable to execute this due to some network error, due to some uh, authentication issue, etc., etc. So once you have the response, once you can go and then you can go and print. So what it will do, it will go and print. So interface data result, it will print, right? I will show you this in the lab. I have lab section for that. Same way, you can see that we have Nexus example as well. So first of all, the import packages, then URLs, then the headers, then the payload. Once you are using payload, remember, once you are using the payload, either this payload will be used in put method or it will be used in post method. So here you can see in the response section, we are using this payload as a post method, right? As a post method we are using, and then you can go and print this with some if else condition. So you can get the response and you can print the response, or you can put like this condition. So if response dot status code is 200, that means is successful, print this, otherwise print the error message. This is something called error handling in Python as well. Let me quickly show you the script. First of all, let me go to my Visual Studio Code point. Here it is. Here you can see that I have added some more functions just to make sure that I am not getting the certificate error. These are the 4 lines that you can go and use in your programming as well. And then this is the device IP, management IP, username and the password, right? And then we are using this RESTconf URL. This is very much like the API. I want the information for gigabit Ethernet 4. Then we have the headers. Then I can go and store that information, the get information, get API information, and verify certificate is false. So I'm storing everything in the response, and then response dot status code, if it is 200, that means successful, print this message, otherwise print the error message. So now let me go here and execute this to get the interface related information for this particular device, iOS XE device, for gigabit Ethernet 4. So what's the program name? My program name is 3.6 underscore a.py. Now here you can see the output. We are getting the JSON output for that interface. See, the interface name is gig4, type is this. So this much of dump information we are getting, right? Now, with the programming knowledge, I can go further and filter. I just wanted IPv4, IPv4 subnet. I just wanted MTU information. Suppose in this 100 output, if you want to filter only 5 or 6 output, then you can go and use your Python skill. And then with that Python skill, this particular information you can print in a table format, you can print in a CSV file, like in Excel format, in PDF format, in any format. And this output can be input for another function as well. So like that, we can manipulate all those things with the Python programming knowledge. All right, so I hope you understand this, and this is the lab example as well. Let's just stop here and move to the next subsection. 3.7. This particular subsection is very small because here you have to go and log into Cisco DevNet portal, and you have to understand that what support the Cisco is providing to learn the automation. That's the whole goal of this particular subsection. So you can go to Cisco DevNet portal, you can reserve the sandbox, you can check the code, that is the code exchange, you can check the support, you can check the forum, you can check the learning labs, you can get the API documentation. So all those information we can get from same place, that is the Cisco DevNet portal. So let me show you all those links that from your side you can go and log into these URLs, create your profile there, create your username with your username and password, create your profile, and then you can start learning all those technology, API and everything. It's like big thing. Like they have added everything, all compute platform, all network orchestration platform, all WebEx, all collaboration, all security, everything is there. So whatever we have studied so far, all those sandboxes, the lab sandboxes are there. The forums are there, the codes are there, the initial configurations are there, everything is there. So if you go to Cisco DevNet portal, here you can see developer.cisco.com. You can reserve the sandbox to do the labs. Like you will get 8-hour labs by default, and you can extend it for maybe 24-hour or 32-hour, like that. 8-hour extension is there, but 8 to 16-hour lab is good. Like for one time I want to do practice for 8 hours. So if you go and utilize these open sandboxes wisely, you will get the sandbox for DNA, you'll get the sandbox for SD-WAN, iOS XE, NX operating system, ACIs, and everything is there. uh, So here you can see I have listed this important information. Testing and experiment with Cisco technology. Yes, you will get the DevNet sandbox. You can go and check this link. Then finding and sharing the code samples and project. Yes, you will get the initial code. You can go to DevNet Code Exchange, and there you can see this link here. So I am here in DevNet Code Exchange place, and I'm searching with DNAC. You can search with ACI, you can search with SD-WAN, you can search with NSO. All those code exchange, all the initial code and projects you will get. You can take some code and then you can modify as per your requirement, right? Learning skill and development. Yes, there are so many learning labs. Like you will get basic labs related to Python, related to Dockers, containers, related to SD-WAN, related to everything. All learning labs are there. You can go and create the notes as well from there. Getting help and support. Yes, they have the support portal as well. Suppose if you are stuck in somewhere and you want some expert advice on that, you can post a query there and someone will respond to you. Then here you can see that you can go and have the engagement with the community. So there is DevNet forum as well. You can share your ideas as well, and you can request for any update, any type of new webinar related to Cisco DevNet, any type of new information. 100% you will get from the forum. Accessing the detailed information on the API. Yes, that's the great thing, like API documentation portal, right? So definite API documentation is there. Again, in that place, at that place, you will go and get the API information related to all different type of compute, network automation, security platforms and all. Right. So this will be a very nice place that you should go and check all those information. Here is an example. So for example, you have some query scenario. You want to build a new integration with Cisco DNA Center API. What you can do, you can go to the resources, Cisco DevNet API, that will provide you necessary DNAC API. So if you want DNAC API, you can go and check the DevNet API documentation. Suppose you want to troubleshoot your script, your network automation script, you can go and check DevNet support. There you will get the help from the technical team, Cisco technical team to resolve your issue. You want to learn something new in Cisco technology related to automation, you can always go and check the DevNet learning labs. Again, if you have query related to that you want some pre-built script, then you can go to the DevNet Code Exchange. There you will get the pre-built scripts, like someone has built some project, some script, from where you can go and take information, like understand those and reuse those codes within your script. You are looking for advice and best practices, then you can go for the DevNet forums. And if you are looking for the lab, labs are there. And what is the lab resource? For that, you can go for DevNet Sandbox. So go and use this portal wisely, and you will get everything related to your CCNA, CCNP, even for CCI DevNet learning as well. All right, so let's stop here. Great job. You have completed to 3.7. In 3.8, actually this video is very important. So in 3.8, we have to understand the model-driven programming options that we have. We have Yang, RESTconf, and NetConf, and how we can go and utilize this in Cisco environment. From our previous recordings and sessions, we know about the Yang, RESTconf, and NetConf. What's the use of these methods, right? So let's go in these methods. Let's try to understand these methods one by one. Yang models, this is the data modeling language, and these models will be used. Uh, Obviously, this model will be used. Primarily, it is used in NSO environment, but this model will be used to create configuration, to do some configuration, to do overall configuration management. And you can, with these model languages, you can push the configuration to multi vendor environment. It's not only for Cisco environment, but it can be useful for other vendors as well, like F5 load balancers, firewalls, Cisco routers, switches. Everywhere these models can be used, because most of the vendors, they are supporting this data modeling languages. So what's the step for Yang models? Identify the Yang model, find the appropriate Yang model. This is the modeling for the data. For configuration and operational data that we want in our infra, Cisco provides many standard and custom Yang modules. Understand the model and utilize it. Use the tool. Tools like Payang can be used to validate and visualize the Yang model. So one of the example here, that suppose if you want to see the interfaces detail. Now this modeling language is very much simplified in a way that you will get the key and value pair. So for example, if you want to know about the interfaces and the parameters within the interfaces, so this is the model example for interface. And then you can see IETF parameter in XML, NS, Yang, IETF interfaces. So interfaces, obviously interfaces, list the interface. What are the key for the interface? Name, obviously interface name is gigabit ethernet 00. So obviously that is a string. Type is a string. So here you can see key and value. Key is the name, value is the value that you will go put in terms of a string. So this is the key and this is the value. Likewise, description. How you will go and give the description? Description will be some string value, some characters, right? Then what's the status of that interface? It is Boolean. It is either up or down, true or false, right? So this is the condition for that. This is one of the example related to modeling the interfaces. Likewise, you may have anything like any type of configuration or sub configuration can be modeled, can be configured like this. And obviously I told you earlier that Cisco has good examples. They have good supports related to standard and custom Yang models. Next in the line, we have the RESTconf. We know about the RESTconf that will go and use the HTTP methods. We know about these methods like get, post, put, delete, and few of the lab examples we have performed earlier as well related to RESTconf. So interesting point here to understand is this, that first of all, you should go and enable this RESTconf in the device. Otherwise, it will not work. So you have to go to your devices. Suppose iOS XE, I have iOS XE device, I can go to the configuration mode and I should do IP HTTP secure server, and then I should go and enable the REST conf. If you go and run these commands, then REST conf will get enabled. And then as a payload, here you can see as a payload, we may have the payloads related to send receive data in terms of XML JSON that can be used with help of the modeling languages, and we can configure that. So here you can see that we are using curl method to get some interface information. So that's the interface information. With the curl method, that will go and use the API method. That's the RESTconf API method. And then we are getting the output like this. So interface name, the description, enable or disable or not, right? The same thing in terms of modeling. So you can see that we have the model where we want the interface description and the true or false value, like it's enable or not. So same modeling language can be used within the API, within the REST API, and then you can see the output, right? So kind of integration of your Yang modules to the REST-conf. Next in the line, we have the netconf. Netconf is a networking management protocol that provides mechanism to install, manipulate, and delete the configuration of network devices. It uses XML encoded data. So data encoding is, data format is XML encoded, and it is running over SSH port number 830. So in the lab, I will show you that we are specifying port 830, and with help of that port number, it will go log into the device, and then you can go and install, manipulate, and delete the configurations. Right. So for netconf also, you have to go and enable the netconf yang. So you should go to conf t in your router, and I have enabled this in my lab setup. So I should go here. So what I have done, I am enabling netconf and then yang. Data modeling language yang, that is integrated with netconf. Likewise, you have seen earlier that we have the data modeling language yang integrated with the REST-conf, right? So here we have the integration in terms of yang modeling language for netconf and netconf. You can see important point here is this: establish a netconf session, use a SSH client or library. That SSH client or a library that will go and connect to the devices is nothing but NC client. NC client, you should have this module installed in the Python library. Otherwise, it will not connect and create the netconf session that I'm going to show you in my lab setup. Send netconf RPC, use remote procedure calls RPC to perform configuration changes and retrieve the data. Right. So let me quickly show you one example related to that. We have the NC client in my, I have done pip install NC client and importing the manager. Then connection to the devices storing as M. Here clearly you can see that port number is 830, right? So we are connecting to the device. Once we are connecting to the device, we are getting the configuration, the running configuration as XML. Once I have the configuration, then what I want to use the new configuration. In that new configuration, I want to change the description over gig Ethernet 2. So with this script, I will go and change the description for this particular interface, and this interface I'll go and make this as a configure by netconf. Configure by netconf, right? So now you can see that payload. Now the same thing that we have discussed, same type of data format we have discussed in the YAML. So this is what? This is one of the example related to, see, model is different thing, and while you are pushing the payload is different thing. So model, you can get inspiration from the model, and then you can create your own code. So if you check this particular code, this interface XML UNI ITF XML, this entire code, and then interfaces. So let me go and show you the data model that we have. So the data model that we have this namespace for interface, and then we have container for interface name and type, description, type, and the state, it's true or false. So enable state, true or false. So now we'll see here that as per the Yang modeling, we have the name, we have the interface, container interface. In that interface, we have the name. For that interface, we have description in the string format, right? It is in the string format, and then enable is true. And then we are closing the interface, we are closing the interface container, and we are closing the config. That is very much XML style. Whatever things you are opening, you are closing that, right? So this way you can go and run the program. So let me quickly go to the Visual Studio code point that I have. Here you can see. So here you can see that we have the program for NC client and connecting to the device. This is my CSR router. Yeah, I'm using port number 830, username and password. And then I want to connect. So if I go here and if I have my But let me quickly log into the device and let me show you first that what is the configuration over gig 2. So description configured by netconf. Already I have done some configuration here. And what about gig 3? If I go to gig 3, so it is not there, right? Nothing is there. So what I'll do here, I'll quickly go and change the interface name. Instead of interface gig 2, I will go and change the interface as gig 3. So here I'll go and make this gig 3, right? And then I will go and run this program. So let's go and run this program. So python.exe, and what's the name? 3.7. Let's run this. And while it's going on, let me go and open this interface. And if I go and check the interface, now you can see it is configured by netconf, right? And then you can see the output. This output is nothing but printing the config. You are printing the config in the XML format, right? That's a big output in XML format. And we are taking this particular config and we are putting this in the new config. So running config. So now you can see target is running, right? Target is running and the config is new interface config. So from this config, we are only changing the interface description. Enable is to, this is the modeling that we have. All right, although this is very interesting video, and if you need to watch this twice, you can go and watch this twice. You can create such type of programming and you can test the result as well. All right, let's just stop here. Great job. Now we are in 3.9 and you can see that within 3.9 we have three subsections. So 3.9 A, B, and C, where in A you have to understand the API related example, that how you can get the list related to Meraki, Cisco DNA, ACI, SD-WAN, or any one of these examples or combination of two, because once you go and learn the things related to DNA and SD-WAN, automatically you'll understand those things are true with NSO or any other platform. Then 3.9, we have managed spaces. This is something like very interesting. This is related to the collaboration, Cisco collaboration portfolio, where we have to understand the managed spaces, participants, and messages in WebEx. That we'll see that in this section. And then finally, we have one subsection C, where we have to understand that how we can get the list of clients hosted in Meraki or Cisco DNAC. Here you can see this is OR. So what we can do that we can learn both and then we can perform a lab task related to one. Whatever open sandbox we have, we can go and perform the lab task. So open sandbox related to DNA and open sandbox related to SD-WAN, we already have. And in my lab section, you can see that. I will give you the URL, username, password that you can also use. Even you can use the same script in your infra as well, and it will work. Right. So let's start 3.9a because these are big chunks. So what I will do, we'll go and record separate videos for all these sections. So let's go and check 3.9a where we want the list of devices from these networking, automation, orchestration tools. Now we have discussed this already earlier in the Meraki section long back, that you have your import packages statement, your URL, your username, password, your header, and then you have API. Here you can see API is get API. I'll get the information related to network. So once you will get the information related to network, your job is done. Your API is done here. With that API, you are getting the network information and that part is done. Then you are using Python knowledge here. So here we are using the knowledge of Python. We are taking, so you can see responses, right? And then network. So network having this network information in JSON format, right? So now you can see that we are putting this network. So for network, You can write anything here, ABC, XYZ. So for network in networks, that means you are putting this output in a loop, in a for loop, and then you are selecting the network ID as a ID, network ID, right? Then device response. What is the device response? Equal to one another API we are calling. So here you can see this get API related to devices, right? But with these devices, already we have network ID. So you can see the intelligence here in this Python, that now devices equal to device response. So you have one response here and you have one network ID here. And then what you will do within for loop, again, we are using one more for loop where we are printing the device in network name. And for device in devices, we are using this loop within loop, print the device, right? So we have the network ID information. We are getting the ID here, network ID. And then since in this example, it is expecting just to print the devices. So I can go and print the device, right? Let me show you one more example. And even I will show you the lab as well. So here we have the example related to DNA. And we are generating the token. So one of the function to generate the token. So we have the token. We will store the token. Means at the moment you'll call the function, it will go and generate the token. So you have the token. Now we have the import, we have the URLs, we have the functions, we have the header. Now getting the list of devices. How? So we'll go and use the API for get method, right? What is this? Network devices. So we'll go and collect the network devices. Once you have the network devices, you can see we are putting everything within the devices. So this JSON, obviously this is what this will be the dump JSON. From that dump JSON, what you are doing, that you are putting all the responses in the devices. You want to print the list of devices. So we are running one loop here, that for devices in device, print the devices, right? So again, you can see that this part will be almost the same everywhere, right? But you are using some sort of uh, technique here, where you have the technique, you are using some Python techniques. Here you can see you have your get information, and from this get information you're filtering the devices, and with the for loop you're printing it. Again, this is also easy and straightforward, right? Let's go to the next. This example related to ACI epic, and this is also the same. You can see import a statement, URLs, log into the ACI, then responses. Now we are using post method. Post method is something that you want to create, new object you want to create. Now this post method, so this responses, we have the token. So once we have the token, again, the same thing you will see here, same lines, because here we have the cutting output. So here responses and token, the headers. Now actual API, where it is, the actual API is here. So responses equals to get method related to what? Node.json. Clearly it is telling that the file is in the JSON format, and then we are putting everything in this device container, and then we are using the for loop to print the device list. Obviously, these are not easy examples, and maybe it is not suitable for CCNA level, because at this point of time, exam is expecting to you to understand just how things are working. It is not expecting you to go and write the entire code, and it is expecting that you should know these examples, this list of devices with any of one of the example here. Because we are studying it, we are learning it, so I put all those examples. Why? Because you can see the similarity, right? You can see the similarity in between. So either it's SD-WAN or ACI or anything, you have similarity. For example, with SD-WAN, you can see import the packages, base URL, logging to the device. Logging to the device, once you are logged into the device, and it's very much same that we have in ACI, we are using post method just to log into the device. Once you log into the device, then you can go and run this API, get API, you can see device URL. With device URL, you will get the information of the devices, and then that devices you will go and print in the within the for loop. So one by one, it will go and print within the for loop. Likewise, I have added one last example related to NSO. Import the packages, give the username, password, the headers. Then you have one get API to get the device list, do proper authentication, and finally you can go use a for loop and print the devices. Because we here we have the cut output, so I have put this information here. So you can see that you have the auth equal to http basics, and then you can see that you have username, password, and you are logged into the device. Right. So this is the section that is expecting you to build any of take any of these examples and build the device list. Since I have open sandboxes, let me go to the lab section where I can show you the example related to DNA. Oops. So you can see here example related to DNA center, and in this example clearly you will see that we have the open sandbox here, and we have the username and password. We are generating the token. Here you can see that I have the token, get token. And then within the header, I am putting this token because I need it to log into the device. So these headers we are using here in the header when we are using the API to get the information about the API. Then we have the device information in the JSON format. But since we want to print the device list, we are putting in the for loop. So I can go here, and then what is that? 3.9 DNAC device list. Since this is open sandbox, so it will go connect to the open sandbox and it will give you the list of the devices and the other attributes. So you can see family, hub and switch, Cisco Catalyst, and all those informations, right? That I don't want to give you all the junk information, bulk information, but you can see that how code we are building step by step. You can build the code step by step, you do the authentication, you can get some result, and then you can use some Python trick to print it. Even you can do some beautification, you can print this in the CSV form, you can print this in the table form. All those formats are there. Now let's quickly check the example related to SD-WAN. Now again, you can see this is the open sandbox that I use from Cisco DevNet learning that we have discussed in section 3.7. So what you need, import the packages, then log into the device. So once you log into the device, you can see that you have the responses here. So once you have the responses, then you can go and use the get method. You can see that we are using the get method to get the information about the devices. So once I have the device information, then I can use this for loop where we are putting device within the devices, and we can go and print it, right? We can run this output to print it. So let me quickly show you this as well. So here we are, we can run the Python program, and this is 9 sdwan.py. Again, since we have the open sandbox, this program will go and contact with the SD-WAN we manage, and you can see that with the devices information that we are getting from the SD-WAN here, we have device ID 10.10.11, 10.10.15, system IP, device ID is 10.10.13, and all those information we are getting. So we are getting the list of devices as per as expected in this section 3.9a. Right? Let's stop here. Good job. You have completed up to 3.9a. 3.9b, this collaboration example. We are going to discuss about manage space, participants, and messages in WebEx, but with help of API, with help of programming, how we can go manage spaces, see the list, how we can go and manage the participant in a spaces and send the message in the WebEx, all through via the API. So we have in this particular subsection, we have good examples related to API. And good thing is this, that the format will be the same. So the API structure will be the same. Sometimes we'll go and use the get method. Sometimes we'll go and use the post method, that you will understand about that. What is the prerequisite for this? The prerequisite is this, that you should have WebEx API token. At the moment you'll go and create the account, you have this option to get the API token. And the other thing related to Python, that we should have the request library installed. Pip install requests, so it will get installed in your system. So one by one, we are going to discuss about all those use cases that we have. So first use case is managing a space. List the space. List a space means that you want to see something. If you want to see something, obviously what method you will use? You will use the get method to see the object, to see something. Now here you can see the format, that importing the request, then we have the access token, our WebEx API token. Then within the header, we are mentioning that token. So we have the header, we have the import packages, and then what about the API? We know that here we are using the HTTP method, and you can see the URL. This is actually the API example. This will tell you the rooms. And then you can use this get method here, right? Within the get methods, we are calling the URL with the proper authentication and headers. So once you run this, if this is successful, so you will get success code 200, and then that means API run is successful. Then what you can do, that you can see the responses. So these responses I can go and store within the spaces, and these spaces with the for loop we can go and print one by one. So now we are printing all these space within the spaces one by one, and then we have the result. So then we have the a list of spaces. This is one of the example where we can go and print the list of spaces. What about if we have to go and create the space? Create means what method we will use? We will go and use the post method. Here you can see the post method. That means we want to create an object. While creating an object, we should go and use the post method. So here you can see the method on the top will be the exact same. But since we are going to use the post method, you have to go and use some payload. So here you can see that we have the payload data, and here you have the API. The URL is the API, and this we are putting inside the post method. So putting the URL, putting the proper header plus the payload. So once you go and execute this, you can store all those information in the response, and then this response we can go and store the response.json response in the JSON format within the space, right? And then you can go and print the space, because this action is creating the object. So if you are creating the object, then the post method will come into the picture. Once you create it, you can print the result. So this way we can go and create a space, name new space, and it will be created. So last API call, last script we have done the list of the space. There you can see that we are creating the new space. Now let's go and understand how we can go and list the participants. Again, if you want to list the participants, then you should go and use some for loop, because one by one you will go and print the participants. And since you are listing something, since you are viewing something, then you have to go and use some sort of get methods. Here you can see that get method, right? So here you can see that we have the import packages, we have the headers, and then URL. Within the URL, you can see we have this URL called membership, up to membership, and then question mark means query in web languages. When you are putting question mark, that means you are querying something. So what you are querying? You are querying room ID with a space ID variable. Room ID with a space ID. This is the variable sign. And then you can see the response, because we want that list of the participants. So that response again we can go and put within the participants, and that participants one by one as a participant we can go and print. Right. So what we have done, we have list the spaces, then we have created the space, then we have list the participant. In next, we'll go and add the participant into a space. Adding the participant to a space, that means you have to go and use the post method. So first of all, first few lines will be the same. What new things you have, you need some sort of payload. So I have my payload, I have room ID, that is my space ID, and then personal email I want to add. And while running this, while executing this particular API related to membership, right, I will go and use the post method. In that post method, I am calling the URL, I am calling the header, because this is the token, authentication token, right? Authorization, all those information. And then finally, JSON data in form of JSON. So then if you get the response code 200, that is successful, then you can go and print that this particular participant having this ID. Participant personal email ID is this ID. Right. So what we have done so far, that we have we check these four scripts, list the space, and then create the space, and then manage the participants, and then add the participant in the space, right? So once we go and add the participant in a space, then we have one task that we want to list the message or create the message. So if you want to list the message in a space, again, listing means get API. So we can go and use the API called get. Again, you can see the import packages, the access token, the header. These things are common. Then URL, which API you need. So we want one API related to message where I am querying the room ID with the space ID. This is my query message for this particular API, right? And then this particular URL as a get, because within get you can see we have only URL and header. Why? Because this is not post method. If it is a post method, then comma, you have to give some data, JSON data. Right. So here we are giving the URL and the header. If it is successful, then we can again go and use some for loop, because we want to list A, B, C, D, E, F, G, H, I, J, K, L, right? So then we can go and put the messages in the messages. Then we are running one for loop, that for message within the messages, print this. So one by one, one by one, one by one, it will go and print all the messages. Now suppose if we want to create message, suppose you want to send a message to a space, some sort of creation of message to a space, then obviously you will go and use the post method, right? So here also your import package, your headers, your tokens will be same. Since this is the post, you need some payload. So we have the payload here. In that payload, we are putting the room ID, space ID, and the text message. For example, hello Webex, hello Cisco, etc. You can put here. Then again, we are using this API, that version 1 messages. This is the API. And since this is the post method, we are using the post methods with request package of Python and storing within the responses. So with this post method, we have the URL, this API. We have the header, authorization and content type, and then JSON data. Right. Now, if this is successful, print success message, and then go store this JSON in the message format, and then you can go and print this message text, message ID, right? So it will go and print the information related to the messages to the space. And suppose if somehow it is failed, then throw an error, then go to the else statement. Right, so we have done a lot, managing the spaces, managing the participants, managing the message. All is script example. You can see this script example is as it is, that you can go and utilize this. What you have to go and change, you can go and change the tokens and some sort of space ID and all those user input you can put in these scripts, and this will work perfectly. All right, so let's stop here. Good job. You have completed up to 3.9, and 3.9 also completed up to A and B. In C, we have to go and check one, you can think this as a lab type of scenario, where we have to list the client or host seen in a network using either the Meraki or the DNA center. So we know that with DNA center, with Meraki APIs, we can go and manage the entire infra, right? Now, since we can manage the entire infra, so obviously we can have a look that what clients are connected with these infra. So making this little bit easier to understand, let me try to explain here that what are the parts we have related to the things that we are managing from the network or orchestration platforms. Actually, three things are there. You have network, so that means we have network devices. Then you have application, right? What applications are running like HTTPS to HTTPS, TCP, UDP, and all those things. Then the new thing that we have in all these SDN environment, that you can monitor or manage the clients as well, like wired client, wireless client, and which particular client is using which particular application. So now if you go and glue all three, so why you want network? To run the application. To whom you are running these applications? For the clients. So that means you have full visibility, complete picture you can see. In other words, you can say that that will be related to network, application running over network, and the client, right? So these informations you can get from API. In this lab example, suppose we want to see the information related to client, right? So either you are using Meraki or DNA or any type of SDN framework. The point here is this, that what are those API? Are you able to recognize those APIs which is serving this purpose? If those APIs you can recognize, you can go and use some methods, some scripting methods to get the result as per desired output. So for example, we want to use Meraki API to retrieve this. Obviously in Meraki, again, whatever programs that we are writing, the same way you can write this program as well. So how it is, first of all, we have to go and use some sort of import statements that we can go and use. So import the request because you want to call the APIs, then the API key and the ID URL. Then we have the header where we are calling the key, right? Then the URL, you have network, then you have variable and clients, and then the response. In the response, we are using get method where we want the URL and the header because we want to see the network clients or host. So that's why. So now you can see that we are storing the client within the response.json is stored within the client, and then we'll run the for loop, and then we can go and print the clients. Easy, straightforward. There is no problem at all in this, right? Get the API, network ID, the endpoint information, and this is the API. This is the API for the endpoint. This is for the endpoint, not exactly the endpoint, but you can see for the client. Client and endpoint both are different thing. In endpoints, you may have multiple clients, right? Some clients or some multiple users, like A user or B user may log into same endpoint or host, right? Anyways, so either it's wired or wireless client, you can get that information, and the result will be like this: K123 client, MAC address, IP, user 1, user 2. Like that, you will get the output in the JSON format. Again, you can print this output in any format. Then let's take the same example with DNA. The point here is this: the consistency. Either you are checking these informations in Meraki or in DNA or any other SDN platform, the the format that you are seeing here on top, you can see that you have import statements, then you have the URL, then you have some functions. Even you have some functions. In that function also, you will go and use the methods that is defined almost in all the programming, uh, almost in all the network orchestration platform, right? So suppose we have one function called get the token, because this token we are going to use, because you know that you need some token. Maybe the DNA will generate the token for 60 minutes. Within that 60 minutes, you have to go and execute the complete task, right? So here you have this package. importing the packages, then URL, and then there is one function get the token. How to get the token? There is API for this. You can see that API for token, and then you are using post method. In that post method, you can see clearly that within that post method we have the URL, username, and verify false. This certification verification false. That means you are returning the token. With Python function, you are returning the token. So once you have the token, right, then you can see that we are defining one header where we are putting the token, right? So within the header, we have the token. So now your phase one is done. Now phase two, what you want to get the client information. So you will see that okay, we have the information related to client detail. This is the API to get the client detail. Parameters are timestamp, which particular time frame you want that information. And response, you can see the response is get URL header. This header is what? Where you have the tokens. Parameters, this is your parameter, right? And then you have the verification, certificate verification false. Then if you are getting 200, that means your API execution is correct. Then we are storing the response within the clients, and then using the for loop, running this for loop. So it will go and print. So with this condition, it will go and print the clients one by one, one by one, one by one, right? So that means that if you see the next page here, you will see that this is the output. We are getting the response because this is the DNA output, DNA based appliance output. So you can see that host name is wireless or wired, client one, MAC address, IP address, and the connected device is access point or connected devices switch. Like that, you will get the output, right? So very straightforward program for Meraki and for DNA, and both are very much similar that you can go and use and you can complete your section. So all right, we have completed section 3. Let's stop here and then we'll go and start section 4. Good job, everyone. You have completed section 1, section 2, and section 3. That is actually overall 50%. Let's start section 4. In section 4, we have to understand about application deployment and security. I can see that overall weightage is 15%, but number of topics are huge. You have to learn from 4.4 and up to 4.12. Here you have to understand about the edge computing, cloud system, virtualization, CI/CD pipeline, Python, little bit of Python, Docker file, Docker related information, little bit security as well, right? So a list, this you can see the topic, the list is long, and even if you go and spend some 30 minutes per section, so you can see that it will take approx 5 to 6 hours to complete this section, right? So what I will do, because this is fast track training, I will go and try to complete one section in between 15 to 20 minutes. But if there are subsections like you have dot 1, dot B, and dot C, so obviously it will take near about 30 to 40 minutes, right? So if one section will take 15 to 20 minutes, if you have subsections, then it will take time. But anyways, the important point here is that we should understand each and every concept, and we should understand the automation behind these concepts as well, right? So let's start with the fairly simple topic, that is 4.1, edge computing. Now we know about cloud computing. People know about cloud and cloud computing, but what is edge computing? Edge means obviously on the edge, that is to the near to the source and obviously near to the destination, something in the edge, right? So edge and then computing. So your computational power that is not there in the data center. You can think like this, that suppose if we have one full-fledged architecture means suppose you have your data center DC1, DC2, and then you have different branches, branch 1, branch 2, branch 3. So obviously you have the connectivity from the data center to the branches. Point here is this, that irrespective of the data center and these branches connectivity, you are not dependent. So your traffic is not dependent. So suppose if I have one user here, suppose this is the user here in the bottom, and if this particular user has to go and utilize some resources, so he will be not depending upon the data center resources, but he can go and use the resources locally, right? Because here at the branch level, suppose this is the branch, here at the branch level, you have that type of computational power. You can take decision at the branch level. You have the source and destination near to the branch. And that's the overall origin for edge computing and any type of new innovation that is happening at the moment in the market, right? So let's quickly check that. You can see once we have the edge computing, then it will reduce latency. Why? Because source and destination, they are near. And before diving deep into point number 1 to 11, I have created summary slide. I'm showing you that slide first, but in this section, you will see that I have added those detailed few lines about those information. So it is there, right? You can see it is there, all the points. So let's go to the summary slide, and these points that you can see here, that is for your reference. Uh, Obviously, once if you're watching this video, that means you have this document access as well. This in terms of PDF or in terms of some URL link hosted in website, those accessibility you should have. So you can go and parallelly check the documentation as well. So this document is available for everyone, right? So you can go and refer these notes that we have here, right? So let's go back here and see the benefits of edge computing. Reduce latency. Why? Because if in between source and destination, your connectivity is good, then latency will get reduced, right? Now source and destination, if they are not far away, that means if your source and destination, they are locally hosted somewhere, obviously the latency will reduce, and that's the point we have with 4.1, means in this section. Point number 1 is reducing the latency. Then bandwidth optimization. Why bandwidth optimization? So if you go and check here, bandwidth, obviously they are local. Data are locally processed, and only relevant information is sent to the cloud, optimizing bandwidth using uses and reduce the cost. The bandwidth optimization is there. I told you earlier in the diagram. Let me show you that one more time. So I told you that the computation is happening locally. Locally, you are reaching to the destination. So that's why your bandwidth optimization will be enhanced, because you are not going to some central store and then using the cloud resources or any other resources. Then enhanced security, including this, privacy and security, because data, they are local. So in that way, we have the good amount of security. And not only that, you can go and apply a different type of secure tunnel like IPsec tunnel, and then monitoring, and then cloud hosted gateways like Cloud Umbrella or GScaler. They are connected with the edge devices, edge computation devices. So that's why the security enhancement, privacy level will be more. Even to enforce the security, it will be easier. You know where you are enforcing the security principles, so that will be easier in this scenario. Improve reliability and resiliency. Yes, it will go and improve the reliability and resiliency, because the computational devices that we have, they are in the redundant manner, they are in the redundant fashion. So if any failure is happening, it will go and provide you resiliency, because you have multiple nodes in a fabric. And same is true with this scalability and flexibility as well, because you can go and add more edge nodes on demand. As I told you that we have local data processing that will ensure the compliance and the data sovereignty, and that is as per law. So there are different organizations that they want that their data should be locally hosted. For example, banking sector, the government sector, the secure network. The first principle for secure network, that data should be processed and stored locally, right? Then enhance user experience. Obviously, if you are matching point 1, point 2, point 4, point 5, then obviously user experience will be good, will be enhanced. Why? Because your throughput is good, your latency is less, your bandwidth is better. So you have very good user experience. Plus, this type of system is suitable for new innovations as well. So you can easily go and integrate, enabling emerging technology, easily go and integrate with new technologies such as artificial intelligence, 5G, IoT, etc. Because you have very stable system where you have low latency, high bandwidth, high level of security, reliability, resiliency. So enabling emerging technology is safe, and it's suitable as well, and it's fast as well. So since we are meeting point number 1 to 6, uh, I was the point number 1 to 6 and then 7. In that fashion, if you go and add all these points, if you go and bandwidth, less latency, high throughput, more reliability, more security, it will be obviously cost saving. So this overall architecture design itself will save the cost. Right? I have already discussed about the enabling of emerging technology. Then contextual awareness. This is one of the key feature we have. Contextual awareness. That means the contextual information related to different technologies. Not only it can store those informations, but it can share these information to some third party as well for further enhancement, for further processing. Right. So it has the contextual information such as location, environment, and user behavior. This is very interesting thing, user behavior. And if we have such type of information, such type of granular information, then these contextual information can be input for any AI machine or AI tools. So then the AI tool or machine learning tool, they can go and create some behavior pattern, and then it can give you the feedback. So this is the user experience feedback. On basis of that, you can create some new policy, some new rules. So it is very interesting, important for the enhancement purpose of the existing environment, of the existing running system. Then finally, autonomous operation allows device to operate independently in the environment. So it's autonomous, it is not dependent upon the other factors that is there in the data center and all. So you can see your devices can go and take a decision locally. It can locally process, locally do anything. So it is not much more dependent upon the data center devices or HQ devices, which is centralized present, because it can go and take autonomous decision. And if this site will fail also, there is no problem with the other systems as well. Other system can work as it is, right? So if it is working as a autonomous system, if the operation is autonomous, so this is crucial for remote or mobile applications such as drones, remote sensor, and edge robots, which may operate in the environment with little or limited intermittent connectivity. Obviously, independently, you have some business independently, you can go and locally host that business at that particular edge computing, and it will run. Great job. So we have completed all those 11 points that was listed, and here we have the summary. You have summary in this format as well, you have summary in this format as well, and you can make your own notes. All right, let's stop here. In 4.2, you have to understand different type of application deployment models, that is private cloud, public cloud, hybrid cloud, and edge computing or edge. In previous video, we have discussed about edge computing. In this also, we'll go and discuss about edge computing with respect to all other cloud option. Now, cloud is nothing but someone else data center if we are talking about public cloud. So you can see that cloud, we have basically two types of cloud, private cloud and public cloud. And if you mix private and public, then you will get the hybrid cloud. That's the third variation we have. Private cloud is nothing but data center. So when we are talking about private cloud, that means that we have our own network, own storage, own compute, servers and services. So in that case, in case of private cloud, we have full control over the compliances, over the hardware, overall the entire infrastructure. On the other hand, public cloud, that means someone else data center, it will give you great flexibility and some sort of cost benefit. And we'll see that chart as well. But on the other hand, because this is someone else cloud, so it will work as a pay as go model. So whatever services you want, you pay and you use those services. Let me do one thing. Let me quickly go and show you all these slides and the points here. So private cloud in terms of ownership, in terms of location, security, customization, performance, compliance, cost, maintenance, and scalability. Ownership is your ownership. Location is that it is the dedicated data center. That means that it is my location, my on-prem location. High security, customizable, because again, it is it is my data center, so I can go and do the customization. Performance, predictable performance. Again, I have to go and manage the performance. I have to go and manage the compliance. So actually, it is easy to manage the compliance because this is my own data center. And in this respect, in terms of compliance and in terms of security, it will be more compliant and secure because I can go and govern the security and compliance feature within my data center. Cost wise, it is always higher for initial deployment, but in the long run, you will see that cost wise also this is effective. Management, yes, you have to provide your internal management, internal staffing, internal, um, you know, OEM vendor relationship will come into the management, managing the operating system, upgrading the operating system, operational task, dependent upon the tech engineers on all those things. So maintenance is something that you are depending upon different parties. Scalability, it has a limited scope related to scalability. Later on in this video, we have comparative chart in between the private, public, and hybrid cloud, plus the edge as well. So we'll discuss more about that. On other hand, public cloud ownership hosted by major cloud providers such as Amazon, Google, Azure, for Microsoft, like that. Location, it is off-prem, it can be anywhere. Security, it has, you can see, share responsibility in between the party, so in between the company and the cloud provider. Customization, limited to services. Again, it depends. See, nowadays this cloud is also very much robust, so all sort of customization that we can do over the cloud, public cloud, we can do over the private cloud as well. So there is no problem related to that. Point here is this security, and point here is this compliance. Compliance and security is something that if you are using cloud services, so you should go and check the security and compliance related parameters on-prem and the public cloud. That's why we have mix of both. So you will see that in the hybrid cloud option that we can go and mix the benefit of both the public cloud and private cloud. So the network that you want to host in the in the private cloud, you can host it. You don't want your storage will get stored in some place that you don't know, some place in other data center, who is some other party is managing your database and storage and those type of compliance related data, right? So you can go and mix the benefits of both. So what is the major benefit you have with the public cloud? This is pay as you go model and scalability. The scalability for public cloud is very high because it's a big data center, and that can scale up to anything because they will go and manage everything on behalf of you, because they have to manage, the public cloud has to manage different customers. Now mix of both means that hybrid cloud. So whatever we have studied, the degree of ownership, right, with respect to private and public cloud will get mixed here. You have benefits of both, and again it depends. So someone knows private cloud, someone knows public cloud, then only they can go and mix the benefits of both. Otherwise it will be like, it will be some sort of overhead. So you are overutilizing private cloud, you are underutilizing public cloud, or overutilizing public cloud, underutilizing the uh, private cloud, like that. So you should have the balance if you want to use the hybrid. So here you can see the ownership, the location, the security, customization, high customization for private portion with flexibility in public portion. Like that means again the mixture of both. Cost effectiveness, maintenance, and scalability also we can go and check the parameter. I'm going to show you the comparative chart as well. Now, edge computing in video number 1 in 4.1, we have discussed about this. This is very much local to the system. So it is secure, it is compliant, it is fast, customization is there, scalability is there. If you go and add more devices into it. Now let me quickly show you the comparative slide in between all three parameters. So you have the private cloud, public cloud, hybrid, and edge computing. 4 columns you have. Ownership, you can see single owner, third party provider, combination of private and public, and distributed near to the data source. Location, on-prem, cloud, mix of both, near to data. Security high, shared responsibility, hybrid cloud high because it's a mix. High, obviously we have discussed this in 4.1, video 4.1. It has high security option. Customization high in private because this is your own infra, limited to providers offering, high in hybrid cloud, and high for a specific needs. Predictable, the performance is predictable, it is variable, but public cloud performance is good, there is no problem in that. Predictable, you have to go and predict because you have mix of both. It is high because we know about this source, their databases and servers are near, so it has low latency and high performance. Compliance, easily compliant. Sometimes you may heard that public cloud, they are not that much compliant due to some restrictions. So in that case, you can go and use hybrid cloud. Compliance for the edge computing will depend on the local data policy. Maintenance, the cost here, you can see the cost first. So cost, the private cloud, initial cost is high, pay as pay as you go model, optimize it varies. Maintenance, handle internally via the provider, it is shared, handled locally. Scalability, limited to scope, virtually unlimited. So public cloud can scale unlimited. High with respect to private cloud, limited by the edge infra. Obviously, it depends upon the edge infra and the scope of the virtualization in the edge cloud environment. Accessibility, it is limited, it has global access. It has means the first column is private, then public cloud, then you have hybrid, and then you have edge. Latency, you have low, very low. higher varies. So latency is also one factor. Bandwidth, internal network usage, bandwidth is high, optimize low. Reliability and applications. You can see applications here that you can go and have the web application, a scalable application. On-prem on-prem infra, generally we are putting the mission critical workloads. It has mix, and in the edge computing, we have the real-time low latency type of application. So overall, you can see that we have clear picture from these tables and these entries. You can understand that what is the specific use of which particular cloud. Generally, in big infrastructure, in big enterprise network, you will see mix of both. You have private cloud and you have public cloud. Why you have this mixture? Because if you have mixture of both, then you have the features or the benefits of both. So in terms of security, you can use private cloud. In terms of scalability, you can go and use public cloud. So that means the hybrid model will be suitable for most of the use cases. And nowadays you will see that most of the companies, they are using hybrid cloud if that company is based on the services that they are offering related to finance services or government organizations or bank, those type of companies, their data are sensitive, they are using this type of model. Some companies, they don't want such type of compliance data, they don't want the users where they are, and they don't want to registered user within one region. Then they can purely go within the public cloud. So for example, Uber or Zomato, uh, you know that food company or food service company or vehicle service company, their data, they don't want that, they don't want private infrastructure, that their data is not that sensitive, right? They are not taking much information related to critical informations related to government organization or related to financial transactions, so they can use a public cloud. Private cloud, on other hand, yes, government organizations, they can go for private cloud, but for some services they can use public as well. So obviously we'll see that 90% businesses nowadays, or more than 90%, they are using hybrid, and 10% they are purely in the public cloud. All right, so let's stop here. Good job. You have completed up to 4.2. Let's start 4.3. In 4.3, we have to understand the application deployment types over virtual machine, bare metal, and containers. Now, I hope that you know that what is virtual machine, what is bare metal, what is container. In case that, um, obviously you know that, but let me go and quickly brief you about these architectures, and then we'll go and discuss about the attributes related to these application deployment types. Means you can go and install your application over bare metal. Bare metal is a server, hardware server. You can go and install over virtual machine. You can go and install over containers as well. So let me quickly show you the architecture of all those three, and then we'll go and compare. We'll see the attributes related to this, right? So here you can see the architecture for virtual machine, that you have physical server. In that physical server, you have dedicated CPU, memory, storage, networking, and on top of that, you are installing the hypervisors, hypervisor operating system. This hypervisor is nothing but the virtualization operating system. Once you have this host operating system, on top of that, you can go and install the guest operating system. Guest operating system, over those guest operating system, they are working as a VM1, VM2, 3, 4, 5, 6, like that. Now the benefit here is this, that these operating system, these guest operating systems may be any type of operating system, maybe Windows, Linux, Mac, etc. And once you have these guest operating system, on top of that, you can go and install related applications native to those operating system, right? So you can see the stack. You have 1, 2, 3, 4, 5, 6, basically 5. So in that, in between the operating system and the on top of your physical infra, you have hypervisor software, right? That is the architecture for virtualized system. What about bare metal? Bare metal, you have physical server, you have all the components like CPU, memory, RAM, etc. And then on top of that, you have the operating system. And on top of that, you can go and install the application. Next, we have the containers. Containers are one extra level of virtualization. You can see here in the diagram that we have the physical infra, CPU, memory, RAM, and then we have the host operating system. On top of that, we have container like Dockers and other container engine. And in these containers, you can see that we may have container 1, container 2, container 3, and then we are running the applications, and these applications actually, these containers actually, this is container. So the containers running application 1, application 2, application 3, these containers having their own libraries and binaries packages. They have their own library, binary, binaries and packages, right? So that's the reason containers are lightly fast, like they are the fastest. If we go and compare with all three virtualization technologies, you will find that the containers, their boot time is very fast. It's extremely fast, right? So let's see. I told you that we can go and check the similarity and the differences in between them. Obviously, all three deployment models are different, and that's the reason their speed is also different, right? Their speed is also different in terms of because the way that we are deploying the application is different, right? So let's see the virtual machine full OS label virtualization. So virtual machines, we are telling this, they have the operating system level virtualization, and containers, they have process level virtualization, means within the operating system. So here you have one operating system and then you have containers. Here you have hypervisors, then you have VM, like hypervisors, and then you have guest operating system, and then you have applications. So this is very much near to the application. This is, you can say that in between, and this is far away because in bare metal, first restriction you have that these applications, they are not free. Like you have only one operating system. Related to that operating system, you can have all the environment, and then only you can install the application. So that's why they are the best. Then this will be the second, and this is the third in terms of choice for the business process when you want to install the application. So attributes, you can see isolation wise, overhead. Obviously, VM has high overhead, and they have the less because this is some sort of process virtualization, and they don't have because this is flat install. Performance. Obviously, they have the high performance because you are not carving their CPU process memory. Here you are carving the CPU process memory, so they are moderate and near native. This is also lightweight. Containers are really good. Flexibility, multiple OS, multiple apps on same OS. You can see application on same operating system. Here you have multiple operating systems, and again you have to install the app over the operating system. Single OS, so obviously you have less flexibility, right? Scalability is to scale, highly scalable. It needs some more CPU, processor, RAM. So that means you will get the good marks here. Portability, they are moderate, they are high, they are low. You know the reason why. Security, a strong isolation, moderate isolation, because there are some vulnerabilities related to containers and their management plane. So that's why they are highly secure, because they are anyways they are segregated. Management requires hypervisor. They requires Docker type of orchestration tool. They require the orchestration tool to do the management. And bare metals, they are simple, no hypervisor needed. Boot time longer, they are very fast, they are okay, moderate. You can list like that. So now you can see the attributes label differences in between them. And if we have to go and choose, again, it depends. mostly you will go and choose this container option, because if you go for the container option, obviously the speed is good, the resource utilization is good, the scalability is good, performance is good, uh, developing the applications are good, because everything is in a container. Within one container you have all the libraries, binaries, and all those things. So building the application with respect to containers will be always better than VMs, and VMs, they are better than the bare metal, right? So this may be one, this may be two, this may be three, and on the rating of building the application, number one will be the container, two will be the VM, and three will be the bare metal. All right, so I hope you understood these attributes and differences and similarity. Let's just stop here. Good job. You have completed up to subsection 4.3. In 4.4, we have to understand about CI/CD pipeline, continuously integrating and continuously delivery deployment. Like that, we have to understand. Now, I have one flow chart here. Let me quickly show that flow chart. Then I'll come to that slides one by one, where you will see point number one, where we have the source control management, all the codes you can manage within the Bitbucket or GitHub. Then you have the continuous integration. Then you have the artifact repository, continuous delivery, and continuous deployment. CD, continuous deployment, continuous delivery, continuous deployment. Then obviously, once you create something and do the testing at the level of development staging, you will go and push it to the production phase. So you want to monitor, you want to take the feedbacks, and then you want to take actions to do continuous improvement as well, like that. So this is something like, it is like, it is something continuous. It is something like continuous process, that we should go and follow this process to make the code point, to make the code and the development uniform and stable, right? Good. So let's just start with one. We have source control management. The examples are Git, GitHub, GitLab, Bitbucket, etc., where you can have the source code. Like, it will go and manage the repository, tracks the changes, collaborate with the other, pull and push things are there. Actually, this example we have seen earlier in our Git and GitHub section or lab, where you can go and pull the repository uh, from the GitHub, right? Then we have continuous integration. Continuous integration means that you can automatically build and test the applications whenever code changes are pushed to the repository. So you have the code, and suppose if you have any changes, then automatically these type of build servers like Jenkins, Travis CI, Circle CI, etc., they will automatically build and test the application. So this is building and testing the application phase, right? Compiling the code, packages application, run unit test, integration test, and verify the code changes. So this is nothing but your continuous integration. You have some small package, a small piece of code, you want to test it, right? You test it and build it, test it, like that. Then we have artifact repository, where it will go and store the artifacts like binaries, package, Docker images. They will help to run the system, to run the application packages. Examples for that: JFrog artifact, Nexus, Amazon S3. Right. So now we have the repository. We are developing the code and testing it. Then we have the binaries library file. Everything is stored, right? Then what is next? Next, we want to deliver it and deploy it. So for continuous delivery, what we want with continuous delivery means automate the deployment at different automate the deployment of application of different environments. That means that you have prod and non-prod, you can see here the examples, development, staging, and production. So whatever continuous integration means, whatever code we have, we want to test it in development, staging, and production environments, right? And obviously, once you test it, you want some feedback, you want some test failure results as well and all. So those things are actually everywhere. In all the stages, you have all those pages. For example, uh, you have tools like Spinnaker, Octopus Deploy, AWS Code Deploy, Google Cloud Deploy. They are ready to do the continuous delivery, and their components are environment manager management and configuration manager management. So that will make sure that you have the proper environment and you have the proper configuration. You have the proper environment, you have the proper configuration, then only you can go to the continuous deployment phase where you want to deploy something. So what's the function for this? Function is that extend continuous delivery by automatically deploying the code changes to the production after passing test and validation. Right? That's the function. Components are deployment, automation, and rolling updates. Deployment automation, fully automate the process of deploying to production. So the point here is this. The point here is this, that you have your source code, you are upgrading the source code, you have your binaries and libraries and dockers and images, right? And then you are ready for the delivery. So these are the steps that you should have. These are the frameworks you can see. Then you are ready for the delivery. You are making sure that you have your code and you have the environment ready, and then you want to apply it automatically. You want to apply it automatically to the production environment. This is nothing but continuous delivery. Obviously, once you apply, you want to monitor and log. You want to monitor and log. You want to see that after applying, after doing this deployment, what issues you have. So you can see that we are monitoring and logging. Function is monitoring application performance, collect the log, provide alert for issue. And you can see that we have example, Prometheus, Grafana, Elkstack, is Elasticsearch, Logstash, Kibana, Splunk, and so many different tools. But point here is this Elasticsearch, Tash, Kibana. They are the most popular tools for monitoring and logging. Splunk is also, you know, that Cisco has acquired Splunk, and they have paid millions of dollars, I think billion of dollars, to acquire this Splunk. Yeah. So these are the tools where we want to send the logs, monitor, if we want to monitor the alerts, etc. So we can take action. And not only that, but we are monitoring the application performance. What are the components? Components, we have application performance monitoring, APM, log aggregation, collects and aggregate the log for troubleshooting and analysis. So see, this is not a simple thing, CI/CD pipeline. This is actually a big thing. And if you go for DevNet related interviews, this is one of the questions they will ask you. So this is actually very important to understand all these stages, that stage 1, stage 2, 3, 4, 5, 6. Then finally, we have a feedback, loopback, and DevOps. I think here in the chart, I will go and rearrange this. So feedback loops and the DevOps. But anyways, no problem. That's very much okay. So feedback loops. What is the function? Let me quickly go and rearrange this. So what I have done, I have quickly make this 8 and 7. Okay. So now we understood all those things. The feedback loops is nothing but take the feedback. The function is provide feedback to developers and operations about the status of build, test, and deployment. Remember, these are very important terms: builds, test, and deployment. And then obviously we know about the component that some notification tools like email, Slack, other messaging services, and all. You may have the dashboard where you can visually see those information related to health information related to CI/CD pipeline. And finally, in this list, we have the security DevSecOps tools like Snyk, White Source, SonarQube, OWASP Zap. No, So what they are doing, that these security tools, so function is this, that integrates with CI/CD pipeline to identify the and remediate the vulnerabilities. Like vulnerabilities, while you are in the development phase, you may have some vulnerabilities, code related vulnerabilities or development related vulnerabilities that security option DevSecOps will provide. Here you can see that the components are static application security testing, SAST, scan source code for vulnerabilities, dynamic application security testing, DAST, test running application for security vulnerabilities. And finally, you have the dependency scanning, checks for vulnerabilities in third-party libraries and dependency. Yeah, you are using some third-party libraries and binaries who will make sure that that code is uh, that code has integrity, that is secure, you know, that is something that if I use within my application deployment or development, that will not hamper in longer run. How you will go and check the vulnerabilities. So we have the vulnerabilities scanners and testing available in this particular phase. So now let's finally go and move to the final picture that we have. So you can see that CI/CD pipeline. This is the big thing, big learning curve you can think as. This is a big thing for DevNet engineers, that they should understand everything here in this particular flow. So we have the build, test, and deployment of the application packages, right? Starting with the managers or the management, then continuous improvement or creation of the code. Then you are taking some references from the, not a reference, but these are the artifacts like binaries, libraries, and images, Docker, etc. Then you have continuous delivery and continuous deployment. Step number 4 and 5 are very much close to each other. Once you are ready for the delivery, you can do the deployment. Then monitoring and feedback loops. They are something that you are monitoring the application performance, getting the feedback. Even sometimes we are getting the user feedback, application related feedbacks, etc. Oh, so all right, this is the CI/CD pipeline. This is actually very important. I will request you that do some research from your side as well. Try to understand as much you can understand uh, related to this topic. This will help you in the longer run. Good job. Now we are in 4.5, where we have to understand, construct a Python unit test. With Python, we want to construct a unit test. Unit test means you want to test the function. Now, what is happening? When you are developing applications, and that those applications, obviously you want to test all the functions, all the module, all the functions you want to test. Now, suppose if in your application you have 200 functions. So whenever you are testing, you will not go and test all 200 functions, right? Whenever you are creating new function for a specific task, that function only you want to test. Why you will go and test the entire function, entire code package all the time? You will not do that. You want to test the interdependency in between this function and other functions, and you want to test that function. So that's why we have this unit test. For this unit test, I'll show you the step by step. So step 1 up to step 4, create a test file, import the required modules, and create the test cases. And finally, you can go and run it, right? So create a test file means that what exact test you want to do. I will show you in the code. So what test I want to do. So for that, I'll create a test file. I'll go and import the function, because in this, we are going to use one function called unit test. And the class related to unit test is unit test.test case. This is the class. And this, we are importing the package, and within that we have the class. Within class, we'll go and define the functions. So here you will see that we'll go and import the packages, right? Not only this package, but if I show you my program, I am importing the unit test, and then I am importing one other Python function add function from math operations. So in the same folder, I have one math operation.py where I have one formula to add two numbers. That is in the same folder, and that also I want to import. So from math operation, I am importing add. This will go and call the add function, how I can go and add the two numbers, right? So we will have the test file, we have the import, and then we want what we want. We want one class, and in that class, I want to define the methods. And in that method, I have different function for different tasks. So functions are something that will go and do different tasks. Methods are part of class, what I want to do. So here you can see that we have this import statement. Then I have class. The class is test math operation, that's the name. And actually we are using this unit test package.test case. This is the class with two dots. We are defining the class. In this class, we have different methods. In different methods, we have different functions that we want to do. So first of all, we want to create one function, say define function, test add positive number self, and the assured value is if we go and add 1 and 2, and from where is add is coming from here, and where is that program? This program is here. I will show you in the code how it is. So we are adding 1 and 2. Obviously this will 3, and if it equals to 3, why? Because we have assert equal function that will make sure that 1 plus 2 and 1 plus 2 equals 3, then this test will pass. Then negative numbers, -2 plus -3, -2 plus -1 will be -3, -3 equals -3, this test will pass. So two tests will get passed. Then 1 minus 1 will be 0, equal to 0. The third test will get passed. Then finally, you will see that I have one function here. In that function, I have three things to check. 0 plus 0 equals to 0, 0 plus 5 equals to 5, 5 plus 0 equal to 5. So this fourth test will also get passed. Right. So once I'll go and run this program within the main function, you will see that our test, Python test 1, 2, 3, 4, they will get passed, because within the main function, you will see that we are defining the unit test dot main, right? So once we'll get passed, once all these methods will get passed, then we can see the result as well. So you can see that all the steps I have explained here in the slide, that import the functions, then the test case, test math operation, a subclass of unit test, then test method as per add positive number, negative number, positive and negative, add 0. And then we have the assertion function that will check that A equals to B or not. If fail, then test will get fail. Then running the function, then we'll go use the Python and we'll go and run this function or the program. Let me go here. You can see there we have our program, and here you can see the math operation to add A and B. We are calling that here on the top. Then we have the class, we have the methods. Within that, we are using assert thing to check that they are correct or not. Test is correct or not. Let me go and run this test math operation. You can see ran 4 tests in this many second. Okay. Now if I go here and make this 6, and if I go and run, I can see that failures equal to 1. Why? Because you know the assert value 3 equal to not equal to 6. 1 to 6. It is throwing error at this particular function, right? So any place if we go and make the changes just to make sure that test is failing or passing. Now you can see failures equal to 2. right? And you can see, although it is generating the failure at one function, but you can see we have two failure scenario. So this way we can go and develop the testing skill, test the function using the Python unit test. Good job. You have completed up to 4.5. In 4.6, we have to interpret the contents of Docker file, right? Docker file, we know this thing from our previous recording session, that you have container option. If you have container option, that in that case, within same operating system with different containers, you have different applications. But these containers, the building block for these containers, obviously you have Docker file. In that Docker file, you have the instructions, and those instructions are the layer or the building block for the entire container. So that's the idea behind this. That means that if I have Docker file, that is a script, in that I have different instruction to get some Python image. For example, here you can see from Python slim, set the environment, set the work directory. You should have some requirements, like for this application, you need this database, you need this pip files, you need this packages, like that. Everything will be stored in the requirements.txt, and once you go and run this in requirements.txt, it will go and pull all those necessary packages to build the container, right? So now you can see clearly that these instructions, so from Python 3.9 Slim, first of all, with this statement, it will try to pull the Python 3.9 from Docker Hub if it is not present locally. Then setting the environment say Python, don't write bytecode, Python unbuffered 1 means we are setting this as a true, 0 means false, this is true. Then set the working directory inside the container. Within the container, we have working directory, work directory / app, and then we are copying the requirements to the app in the working directory, and then we are installing the requirements. These requirements may be different things, like some sort of database requirements, some sort of pip files, some sort of pip packages, maybe table function, maybe some mathematical calculation. Those packages, those are available within the pip, and we are using no cache because we don't want buffer. So you can see that these building blocks, say block number 1, block number 2, block number 3, slowly, what we are building? We are building the container, right? Then again, you can see that once you have all the requirement installed, then copy the rest of the application code into the container. So you're copying the rest of the application code to the container, and finally you can go and start the application. Now, if you go and set some port number, for example, 3030, 8081, anything, and now if you go and run such type of application with respect to setting some local host and port number, so you can log into that local host and port number, and you can see that application is running and that is in action, right? This is the importance of the Docker file, and it may be big Docker file, contains so many informations, like the database, like the password, some sort of encrypted passwords, the port numbers, you know all sort of thing. Not only that, we can go and have a Python package here, Python application running, but you can have a full-fledged system. For example, you have full-fledged DNA automation server running. You have full-fledged automation servers running with these containers and images. It's quite powerful, and we have so many different examples. And if you are interested, you can go and check the GitHub. There you can get the Dockers. Even you can get the Docker for ACI as well, for DNA as well, for SD-WAN as well. No? So like that they are. Again, you can see the explanation here, the use of from, the environment, the work directory, and then the copy function, and the run instruction, and cmd instruction that will run this application. And then I have added everything here in a summary as well. So base image, first statement. First statement was from the base image, that the images start with this slim base image. If it is not present locally, it will pull from the Docker Hub environment variable that you want to configure Python to run without creating bytecode files and without the buffering std out. Working directory, setting the working directory, installing the uh, requirements, then the application, rest of the code we are putting within the folder, and finally running that function, running that container. Okay, so that's the summary we have. Finally, you can see the some of the useful links I have added here. You can go and install the Docker within Windows. Like you will get nice GUI version, and from there you may have different Dockers. So this is some sort of Docker image, and in your system, suppose I am running Windows system, in that I can go and install Docker. In that Docker, I can have so many different Docker file for different applications, and even I can run this 10 or 15 or 20 Docker file at a time within my Docker, right? Then if you are interested, you can go and install the Visual Studio, that we already have all the programs that we are discussing. You can see that we have this Docker program running here, right? And we need some modification. If you want to do some modification, we can do it. But this is a normal Docker file, and how you can go and run it. Even in the Visual Studio, you can go and search different packages and you can install, right? You can go and install those Docker packages. Then you can see that we have the document link as well. So you can go and check the doc link as well, right? So these are the useful links that you can go and explore on that, and can get more and more knowledge related to Dockers. All right, let's just stop here. Good job. You have completed up to 4.6. In 4.6, we have discussed about Docker file. What we'll do, that will continue that learning in 4.7, and with help of Docker file, we will go and run our container. In that container, you can go and start developing your applications. Right, so same example that we have in the previous section, we'll go and execute that in this particular section. Now, before starting the lab section, we should have our Docker running in our Windows or Linux system. For Windows, it is fairly straightforward, that you can go and utilize, download the exe file, the Docker exe file, install within your Windows. That is very straightforward, right? That is a straightforward. And let me go back. Let me quickly see that if I have given some link here. So here you can see that we have link. You can see desktop for Windows. You can go here, simply download the Docker file and install in Windows. Once you go and install it, you can see that it will be like this. Installing the file will be like this. This is for Windows version. And suppose if you have Ubuntu, then you can go and install this over Ubuntu as well. You can use some Linux command like sudo apt update, then install the prerequisite, update the packages. You can go and add the keys for the Dockers and all. And then you can see that you can go and add the repository. Like these commands you can go and use. Once you go and use these commands, you can go and install the Docker within the Ubuntu. So apt install Docker. Once you go and install it, you can go and check the status as well. Sudo system ctl status Docker. These are the commands that you should go and utilize to install it over the Ubuntu system. Here you can see I have installed in my lab environment in the Ubuntu. So I have updated the packages and the upgradables, then apt install the app transport HTTPS certificates, then downloading the Docker, and then I am installing this Docker. Once you go and install it, you can go and check the status. The status, it will show you the status as a active, right? So once you have the status active, then what you can do, then you can go and pull the image, means from point number 509, we are going to check the steps related to build our Docker image. So here you can see that install the Docker is step number 1, and for that you have all these steps, right? Once you install the Docker, then you can go and pull the image. So I can go and use Docker pull command, Docker pull, and then use this command. Let me quickly show you this, that I have my, oops, this is gone. Let me go and restart the session. I have my Ubuntu system. Let me log into my Ubuntu system. Once I log in, let me clear this and I can go and check. First of all, sudo system ctl and the status for the Docker. You can see it is active, it is running active, right? Since it is running active, now I can go and use the Docker pull command. Actually, it is there, but let me show you that you want to pull that image from the Docker Hub, at the slim version, slim pulling, which is already there. So let me show you this. Already I have pulled this image, so I can show you Docker images, and you can see that I have this image already pulled here, right? So that's good. Let's go back here. So step number 1, install the Docker, done, pull the image, done. Then we have this Docker file. About this Docker file, we have learned, we know from our previous knowledge that yes, this Docker file, what are the steps in the steps or instruction, and these instruction are building block or layers to build the container. So once you go and execute this Docker file, it will start your container where you can go and develop the application. So now I can go and use this command, Docker uh, build the Docker image. This is how we can go and build the Docker image, right? And this command builds an image with tag my Python app, like that. I will show you that. And here you have dot here. After that, you will go and give the dot. I will show you this as well. And then once you have, then you can go and run the Docker image. How you can go and run it? So here you can see that you can go and run the Docker run. It runs the container in the interactive mode with the terminal. I for interactive and T for terminal. Then RM automatically removes, RM for removes container if it exists. Then again, V stand for verbose, and then your present working directory and /app where you want to mount that particular image. And then you have the working directory, the app directory, inside that you want that container to build. And then you are giving the image name. What is your image name? We'll go and select the image name. And then we want to log in with the bash shell. Right. So this is the command that we can go and utilize. Once we have the container running, then we can go and run any of the application, app.py or any of the application we can go and run within the container, because now we have one working environment where we have Python 3.9. So within Python 3.9, we can go and execute any type of configurations that is related to Python 3.9, right? So again, you can see that you have the set up the project and run the container for development, like that, some of the commands. And then if you want to have the cleanup, if you want to clean the container, you have that you can go and do that. Okay. So let's go here and let's run these commands. Once we'll go and run these commands, then our container will be up and ready, and then within the container we can go and execute the develop the applications, right? So let's go. Let me go and open the Ubuntu. I have my Ubuntu machine, and here, so we have pulled the image. You can see that image is there, and let me show you the the file, Docker file as well. So suppose this is my Docker file, and then why not? Let me do. I'll do one thing, that instead of my Python app, I will copy that content in the other function, because my Python app is already in use. Now let me go and build the Docker. So Docker build, and what is my app dot. Now you can see that it will go and build this image with respect to all the command items that we have, right? So one, from Docker, then you can see two, that is work directory app, then three, the requirements, putting that requirements right within the app, then run, no cache requirements, and then step number 5. So step number 5, that your image will be there in the working directory, that is my app directory, that the mount is happening. So once this is completed, then we can go and run the Docker. So this is the building phase. Once the building phase is completed, we can go and run the Docker. So let's wait for few seconds. You can see building is taking some time. You can see the time here. It is taking that time. We have completed 8 steps or stages out of 9. And now you can see that exporting to images, exporting layers. So we have built 9 steps out of 10 to build the image. And soon you will see that this task will be completed. Once this task will completed, then what we can do, that then we can go and run the image. So now you can see that it is done. And if I go and check the Docker images, so you will see that we have image 32 seconds, just 32-second back, we have that image. You can see 2.42. But anyways, we have the image built. Now what we can do, that we can go and run the Docker. So let's go and run the Docker. Say Docker run interactive terminal, remove any existing Dockers. I want to see the output in the verbose format. And then we have the present working directory, right, /app, and then the work directory app, and then the image. So image, my image name is, the repository I have is Python, and I want to use bin and bash to start that. Now you can see that I am within the, I am within the container, right? So my container is successful. I am within that container, that is /app. Once I am in this container, if I have any program, so let me do one thing. Let me create one program, test.py, and we'll go and print something. Hello world or something, hello Docker, something like that. Let me go and save this, and let's go and run this one more time. And now I can go here and what is this, test.py. You can see the output, hello Docker, right? So this is the way that you can install the Docker images, and then you can build and you can run, and within that you can go and run the application. What are the benefits we have with the Docker in the local environment? it is consistent, it has isolations, you can reproduce it, and it's very simple to set up. Yes, it is very simple to set up. So suppose I am using Python 3.9 to develop one of the program. Likewise, I can go and create environment 3.1 within same operating system. I may have so many different containers that can run parallelly, and I can develop parallel application, different applications. So that's one of the very nice thing we have, because they are isolated environment, because packages are installed, all the requirements are installed, so they are very consistent. We can reproduce it. I can destroy this development, and I can reproduce it within seconds, within minutes. They are very simple to set up. Yes, they are very simple to set up. Only 3-4 lines of command. What you need, you need all the instruction within the Docker file, and then it will work like anything. Right. So we have a lot of benefit with this Docker, and now you know that how to set this Docker within the Windows system, within the Ubuntu system, and with the help of one of the Docker file, you can go and install it. You can go and install it, and it will run perfectly. All right, let's stop here. Good job, everyone. You have completed up to 4.7. In 4.8, we have to understand about identify the application security issue related to secret protection, encryption, encrypting the data within the storage, transport, and data handling. Now, how we can achieve this task? I'll go and I'll show you all those related important information related to this section. Point here is this, that we want to protect our data. So when you are writing the code, in that code, if you have username and password that is in plain text, or suppose if that code you are storing somewhere, your application, your code base, you are storing somewhere in some storage, then that storage part also you want to make sure that that storage is also encrypted, well protected. And suppose if you are putting your codes in some public domain, in some area that is shared, so that shared or public domain should also be accessed via the proper mechanism, via the API keys and tokens. And apart from that, suppose if your code base is transferring from one place to other place, means if data is in transit, so that also you want to protect. So point here is this, that you want to well document and well protect either your data is somewhere in a storage, it is in transit, and it is in use. You should follow some sort of a standard that you should protect everything. Correct? You want to protect everything. So regarding to that, we have few slides. In few slides, you will understand about all these mechanism, how to protect it. So let's start. This is actually the summary slide, where you can see that you have secret protection, encryption, and data handling, and 1, 2, 3. But before coming to this summary slide, let's see. I have created the slides document related to all this section. So first point is that how we can go and provide the secret protection. What is the issue? Issue is storing secrets such as API keys, password, tokens directly in the code base. So instead of storing directly in the code base, you can go and store this in AWS Secret Manager, HashiCorp Vault, some place where you have all these passwords and all these API keys are stored. And even that vault also, you are regularly changing the username and password to that vault. Not only that you are changing the username password to that vault, but you are providing some sort of role-based access. So suppose if some vault is there and you will not give access everyone to that vault, that means there you should have some RBAC, role-based access, that few members has access to that vault, and few members only can go and change the username and password to the devices all the time, like that. Okay, so we can go and use hard coding secrets, that you can go and use some vault. Insecure secret storage. What is the issue? Is storing secrets in plain text with configuration files or database. So you should go and encrypt your data store. Insufficient access control. Yes, you should go and provide role-based access. You should not go and give access to everyone to all the walls, right? So hard coding the secrets, insecure secret storage, insufficient access control. That is related to secret protection. Then second is encryption in terms of storage and transport. So you are storing your code base somewhere. That means data at rest. There, suppose if you are using without encryption, you do not do like this. Data at rest, you can go and use advanced encryption standard of 256 bit. That is the highest bit encryption we have within AES. And then you can provide and then you can store your databases, backups, etc. So that is very important aspect related to encryption, storage, and transport. Unencrypted data in transit. When your data is in transit, make sure that it is going via some secure tunnel, transport layer security tunnel, some TCP-based tunnel. So if data is in transit, someone can go and sniff that data and can see that what is the API's keys and the username and password, etc. Right? So you should not send the unencrypted data in transit. You should encrypt via some good tunneling method. One of them is the transport layer security. Weak encryption algorithm is also a bottleneck. Do not use MD5 SHA-1 because nowadays they have the vulnerabilities. All the time, keep checking your algorithms, your encryption algorithms, and keep updating those algorithms with the standard one. Whatever there in the market, whatever the highest level of encryption you have, you can go and update with that. Finally, in this section, we have data handling. Data handling. The first point here is that insecure data storage issue. Storing sensitive information in insecure locations such as public folders, improperly configured database, right? So in that case, you should store your data in restricted zones, in restricted areas. Otherwise, this will be big issue. So data handling, first issue is insecure data storage. You should check your data storage where you are storing it. Then improper data sanitization. This is also very important point related to data handling. Issue here is this: failing to properly sanitize or validate input data, leading to vulnerabilities like SQL injection, cross-site scripting. These are hacking techniques. These are something that you have your database, someone can inject some vulnerable code, someone can go and inject some sort of code in that, and then somehow they can get access to some portion of the database, some username and password. These are the injection, SQL, database type of hacking. Cross-site scripting, again, database type of hacking we have, no, scripting type of hacking we have. So suppose while developing the code, if you are not maintaining the proper security parameters, then for hackers, it will be easier that they can go and do SQL injection or cross-site scripting to hack the system. What is the mitigation? Implement input validation and sanitization to prevent injection attacks. You can go and use, again, I told you that you should go and use the proper structure, proper parameter or the process to mitigate from these type of attacks. Use parameterized queries and ORM, object relation mapping tools. Right. Next in the line, point number third, excessive data expose. Yeah, you have API and those APIs are used like anything, like, you can see that issue. Exposing more data than necessary through API or other interfaces. Unnecessarily, you are using the data which is not required. So what's the mitigation? Follow the principle of least privilege by exposing only the necessary data. Least privilege is one of the very key aspects we have providing the data security. Implement proper API security measures. right? Proper API security measures. We have one topic related to API security. We'll see that in upcoming section, upcoming videos. But yeah, we should provide the proper API security measures, including rate limiting and authentication. Final in this list, improper data disposal. What is the issue? Failing to securely delete or dispose the sensitive data. So you're deleting some data and someone can go to the archive and retrieve the data or take the backup or somehow recover the data. That will be the bottleneck, right? So while doing the disposal of data, the mitigation is that you use secure data deletion methods such as threading files and ensuring that data deleted can't be recovered, right? So now you can see all 3 points we have, and here you can see the summary of all those 3. Use a secret management tools, use encrypt data at rest and transit, implement RBAC control, sanitize and validate the input data, regularly update the security practices, secure data disposal. When you're disposing the data, secure it. And now you can see the table that we have for secure protection, hard coding the secrets, insecure secret storage. These are the points. You should secure it. Use RBAC in terms of encryption. Use proper encryption methods. Make sure while your data in transit, use TLS method to secure it. Do not use weak encryption such as MD5 and SHA. Try to use the stronger encryption algorithms to secure your data. Finally, data handling, that your data storage should be secure. Do proper sanitization of data, use different type of techniques for that. And finally, that while you are disposing the data, make sure that they are not recovered. Right, so these are the best practices and additional best practices that your tools should be up to date and regularly update your security measures. All right, so I hope that you understood this. This is very much like informative type of video, that you should use this, you should use this technique, you should use this technique and this technique. This is very much like theoretical aspects. This is very much like the process level aspect. Okay, all right, let's stop here. Good job. You have completed up to 4.8. In 4.9, we have to learn about firewall, DNS, load balancer, reverse proxy in terms of application deployment. Now, these topics are huge. You know that learning firewall, learning load balancers, reverse proxy, they are security appliances. And if you want to learn these technology, it will take some time to learn. In this video, I have to give you brief explanation about what is firewall, where it is used, about the DNS uses, load balancers, and reverse proxies. So let's understand in that perspective. I will not go very much deep inside this. Firewall. What is firewall? Firewall is nothing but it will do the filtering. So firewall can work as a perimeter device. Any packet or any traffic that is coming within the network or within the infra or leaving the infra, firewall, it's responsibility of firewall that it can go and detect those traffic, analyze those traffic, those things it can do as per the predefined rule, it can take action. So here you can see that purpose of firewall is to protect the network from unauthorized access, attacks, malicious activity. Types of firewall, we have network firewall. Within network, you can deploy the firewall, or you may have application firewall. A network firewall, that means it will go and check the network related traffic based on IP address port protocols. Application firewall will go and inspect the traffic at the application layer. So you can think this as a next generation firewall that can do the inspection L4 to L7 up to application layer. What are the common features we have with firewall? Firewall can do packet filtering, stateful inspection, proxy server services, that means on behalf of someone. And it can do IPS, IDS as well. Means you can go to the next generation firewall, install the modules related to intrusion prevention and detection. So it can detect and prevents the security threat in real time. Next topic, we have DNS, domain name service. The main service for DNS is to convert URL into IP, IP to URL to IP. That means if I go to my web browser and if I type www.google.com, so how it works, you are typing google.com, here you are typing google.com, then DNS resolver. So my laptop is a DNS resolver, queries DNS server. Somewhere in a network, you have DNS server. So that query will that query will reach to DNS server to resolve that google.com having what IP address. So DNS server will respond with the IP address, and then you can go and do the web browsing. Right. So it's something like easy to use, like human readable format. That's the URL. URL is human readable. DNS service is that human readable, it will convert to IP addresses. So the request can route to different gateways. What are the components we have for DNS? DNS resolver, that is the client-side component for query. DNS server, who has the database, the record, what is the URL, what is the resolved IP, and then we have the DNS record. Different type of DNS records are there. For IPv4, A records, 4 times A for IPv6 addresses, canonical names, we have MX exchange that will provide the information about the domain names. Next in the line, we have the load balancer. Load balancers are working as an appliance or as a device that can take many of the requests, and then they can balance as per their algorithm. They can distribute the balance over the servers. They can distribute the load over the server equally. They can go and use a round robin algorithm or least connection algorithm or IP hash algorithm. So the chances are that you may have n number of clients or n number of client requests, and you may have only 3 to 4 servers. Now suppose if all the n requests will go to only one server, that means one server will be very much busy to respond all the n requests. So better than that, the load balancer can go either use round robin algorithm or least connection algorithm. It will send the request to server 1 and then 2 and then 3. That's the round robin. Or it will go and check server 1 having 200 connections, server 2 having only 50 connections. So next time the request will go to server 2. Why? Because it has only 50 connections. The load balancers also, they have type hardware and software. Hardware, obviously, that is the physical appliance. Software is something that is running on a standard hardware as a virtual, means as a VM over the virtual machine. So over any hypervisor, you can go and install the software form factor. Right. Apart from that, they have additional features. So load balancers can go and check the server health, and according to that, they can shift the load. They can do the SSL termination. That means they can go and offload. So they can decrypt the SSL traffic to reduce the load of the application server. Means offloading the load to the server while they are doing the SSL decryption and sending the traffic to the application servers. So application servers, they will not decrypt the traffic, otherwise they will be very much busy decrypting the traffic. So some device in between decrypt the SSL traffic, take that CPU process at that intermediate device level, and then that request will go to the application server. Application server role is just to respond for the query. Apart from that, it has feature called session persistent. Suppose that client, they are always routed to same server. Means, you want persistent connection between client and server, some constant connection between client and server. So that session will be maintained via the load balancer. These are the features of the load balancer. So only 2 slides, but you can understand that load balancers used to offload the burden, provide the efficiency in between client server communication, provide the consistency, and doing the equal. The final we have in this list is the reverse proxy. Reverse proxy. Proxy means on behalf of something. The reverse proxy is a server that sits in between client device and the backend server. Now, with help of a reverse proxy, it will go and improve the security, performance, reliability of application handling by request on behalf of backend servers. This point here is this: very much like load balancers, the reverse proxy can take so many requests from client and then it can balance the load. You can see balance the load in between the client and the server. But since reverse proxies, they are hiding the actual IP. So you can see they will go and provide the security as well because they hide the IP of the backend server. So reverse proxy, they will improve the security. They are doing the load balancing. Apart from that, they are doing caching as well. So if you have common source and destination communication going on, so those clients have some cached information. So next time onwards, the transaction will be fast. The caching is a service that store copies of frequent request content to reduce the load on the backend servers to improve the response time. Then SSL termination, that already we have discussed about that. It will do SSL or TLS encryption to reduce the load on the backend server. Then it can do compression as well. That is one of the algorithm that will reduce the load and it will enhance the bandwidth. So you can see that with reverse proxy, we'll get benefits of security, load balancing, caching, SSL termination, and compression. These are the features that we have with the reverse proxy. And common use cases are such as web acceleration. It will go and accelerate the client and server responses, and API gateway. That means the routing API request to the appropriate microservices and managing API security. It is working as a gateway as well, API gateway as well, and it can accelerate or enhance the performance. Now here we have the summary table. You can see all the security components, the role of firewall, protect network from unauthorized access and attacks. It is doing packet filtering, stateful inspection, IPS, IDS, DNS. It will translate the URL to IP. Key features are DNS record resolver servers, load balancers. It will go and manage the load in between the client and servers. Apart from that, it has features like load balancing, health check, SSL termination. Likewise, we have the reverse proxy that will provide you security, load balancing, caching, SSL termination, and compression, and it will improve the overall security and the performance. So these are the security appliances we have, very useful appliances we have. And as a network associate engineer, we should know at least the basic features of these appliances. Great, you have completed up to 4.9. In 4.10, we have to understand the top OWASP threats, such as cross-site scripting, SQL injections, and CSRF. Like we have a list. Here you can see that top threats. We have XSS, SQL injection, cross-site request forgery, injection, insecure deserialization, security misconfiguration, broken authentication, sensitive data exposure, using components with known vulnerabilities, and we have this insufficient logging and monitoring. So these are the top threats we have in the category of OWASP. OWASP is Open Web Application Security Protection. They are publishing the top threats, right? Top security threats to web application. Now, if you go and read these names, you'll understand what is these threats all about. So if we have some SQL injection, that means SQL is one type of database. That means somehow, they can go and put some unwanted code within the database. So if someone can do this, and if someone is successful doing this, that means he can go and alter the database entries, edit, remove, all those things he can do. So what I have done that in this upcoming slides, you will see that what is this threat and how it is happening and what is the mitigation rule. But if you go and check the threat's name, you'll understand sensitive data exposure, security misconfigurations. These are some sort of misconfiguration. Like this is some sort of misconfiguration. Or if you're writing your code, you are using some known vulnerable libraries or packages that will be this threat, that will fall under this threat. Or if you are giving full privilege to unwanted unwanted what you can say, not unwanted but untrusted user, or users which are exposed somewhere. So in that case, you have some sort of you have to go and use some sort of role based access control and all. Let's understand this. You can see in this list that top 3 or 4, these are the top 3 or 4, but I have made this presentation that you have all in the list, like all 11. Again, these are again the top 11 threats we have. So we have cross-site scripting. Cross-site scripting, as name suggests, that attacker injects malicious script into the content from otherwise trusted websites. The script are then executed in the context of the victim's browser, right? So how it is? Let's understand. This is stored XSS. The malicious script is permanently stored in the target server, right? It is in the target server in the database. Then we have reflected XSS, that is cross-site scripting. The malicious script is reflected off a web server, such as the error message or search result. Or the vulnerability exists in client-side code rather than server-side. So this is not only, means this threat is not only for the servers, but client-side also, it can go and execute such type of vulnerable codes, malicious scripts, right? What is the impact? Stealing the cookies, session token, or other sensitive information, defacting the websites, redirecting users to some malicious sites. What is the mitigation? Mitigation, you can see, escape untested data based on the context. Just be aware that you have some untested data and do not trust on those data. Use content security policy, CSP, to reduce the impact of cross-site scripting. And finally, validate input on the server side, right? So again, I told you in the summary, mostly these are some script level threats, vulnerabilities. Mostly what they will do, somehow the attackers, they have access to either the server side or the client side users or the server side service providers. Somehow they can go and inject the script in the website, in the database, right? And while doing that, they can corrupt the database, they can corrupt the website, and from that website, even they can go and take the admin access to complete application, to overall application. You know that in application you have front end and back end. So from front end, that's the user interface, they can enter, and somehow they will go and put some malicious code in the backend where you have your server, and they can go and corrupt the server side data as well, right? So that means that when the servers, they are getting those requests, they should get those requests from trusted parties within some tunnel. Those requests, that servers that they are getting, they should be somehow they should be corrected, or somehow they should be scanned, right? They should be authenticated, they should be validated with some other tools as well, right? So here you can see that first in that range is XSS, cross-site scripting, that somehow the piece of code will be affecting the server, or they are affecting the client side. Next, you can see SQL injection, as name suggests, that SQL is a type of database that they will go and somehow they have the partial access or full access to the database. If such type of things will happen, then unauthorized access to database, data modification, deletion, compromising the entire database server. What are the mitigation tools we have? You can use the ORM, Object Relational Mapping framework, that automatically handle query parameterization, validate and sanitize the input. This is actually valid for most of the use cases. Validate and sanitize the input. If you are validating and sanitizing the input, that means that is your first line of defense. Use parameterized queries or prepared statement. Right. So these are related to database query. Use proper database query as well, and those proper database queries should be authorized. So those queries only authorized. So someone can not do any type of query to the database like that. We should have that relationship. Then cross-site request forgery. How it is? CSRF involves tricking a user into performing action on a web application in which they are authenticated without their consent. Somehow, authenticating the website which is not authenticated or authorized. What is the impact? Unintended fund transfer. Wow. Somehow someone will go and log into your net banking, get the session token, username and password, and they can do the fund transfer. This is type of hacking as well, right? Hacking, fund transfer. Changing account setting, including password, email addresses, performing administrative functions. What are the mitigation? Use anti-CSRF tokens, validate the origin and refer the headers, implement same site cookie attributes. So in that case that you are using some sort of anti-CSRF tokens are very important. Tokens are some sort of OTP, one-time password that will be valid for 30 seconds or 60 seconds or 1 minute or 2 minutes like that. So you have some sort of token that will be unique. So someone will log to the net banking and other sites. Once they have the token, they will go and put the token, and according to that they can log in. So your sessions, if someone will go and hack the session, still it will be difficult to steal the credential in the normal format, in the same format. Right. So we have the CSRF, cross-site forgery. After that you can see injection. Again, injection means that we are putting unwanted code within the application. If you do that, then you have impact related to data loss, corruption, loss of accountability, full system compromise. What is the mitigation? This is actually very important. Mitigation: use safe API. Safe API. Avoid using the interpreter directly. Avoid using that interpreter. Skip special characters in input. I told you earlier, all the points you have some sort of input. Validate the input. Your input should be correct. And in this injection, you can see that we have one very important aspect, that you use safe API. Make sure that API that you are using in your program is a legitimate API, safe API to use. Then now we have some more points like insecure deserialization. Insecure deserialization happens when untrusted data is used to abuse the logic of application, inflict a DOS attack, or execute arbitrary code. This is something like a remote code execution, elevation of privilege, DOS type of attack. Right. Again, the mitigation is avoid accepting serialization objects from untrusted source, use integrity check like digital signature to detect tampering, monitor deserialization and data integrity. So now you can see that I have a list. I have list of threats here: cross-site scripting, SQL injection, CSRF, injections, insecure deserialization, then you can see misconfiguration. So I will simply share these documents. So while you're watching the video, that means you have the access to these documents as well. And you can go and check these points as well, because as per the syllabus, we should know 3 or 4 threads. Likewise, you can go and check other threads as well. And I'll go through it, like quickly I'll go through it. So next in the line, we have the security misconfiguration. That means that you are doing some misconfiguration at application level, including the platform, web server, database framework, etc. While doing that, exposure of sensitive data will happen and unauthorized access to default account, unused pages, unpatches, flaws, etc., etc. Something like um, you are not using professional way to develop the application, and then you have so many loopholes within the application, within the software, and with that someone can detect that, and then they can do the unauthorized access to the accounts and all. Then broken authentication, this is also very important, and we have seen this in our earlier examples, that you should go and use the session token. So in DNA example, we have seen that it will go and use the token API. Once the token will get generated, then with that token, we are using that token within the get API or post API or delete API, etc. So suppose if you have broken authentication, so someone can go and steal the session. In that, impact is that user account compromisation, data threat or manipulation, unauthorized access. Again, mitigation is that use multi-factor authentication, strong algorithms, use secure mechanism for session management. So you can go and manage the sessions as well. Sensitive data exposure. Again, you can see that sensitive data exposure, as name suggests, that your sensitive data should not put within the public platforms. Somehow, if they will get exposed, then identity threat can happen, financial loss can happen, legal repercussions will happen. And mitigation is that encrypt the data, use a strong cryptographic keys, limit the data exposure. Right. So likewise, we have few more points. Using components with unknown vulnerabilities. With the known vulnerabilities, actually, known vulnerabilities means that while developing the code, that this is the vulnerability. If I develop my package with this vulnerability, something unethical will happen, something will happen, right? But I don't have other options. So programmers, sometimes they are hiding this with the higher management or the project managers, and now somehow they are developing this thing. They know at programmer level, they know that there are some vulnerabilities and it should be mitigated, and then it should be used. But due to some timeline, some what you can say, some lack of again professionalism, or they have to submit the project within that time frame, something like that. Somehow people are knowing that this piece of library or this piece of code is vulnerable, still they are using that. While using this vulnerable code, then what will happen? What is the impact? Exploitation of unknown vulnerabilities to compromise systems, data breaches, corruption, full system compromise. Then again, you have the mitigation tools, mitigation options here that you can have a look on this. Then insufficient logging and monitoring. Obviously, we should have role-based access. We should log the sessions. We should log the development phase. All those things we should log. The impact will be delayed detections of breach, incomplete forensic analysis, unidentified and unquantified attacks. Right? What's the mitigation? Implement comprehensive logging and monitoring, regularly review and analyze the log, establish an incident response plan, IRP, incidents response plan. So these are the important factors we have related to top threat. Now what I have done, that I have added this chart, the summary chart here, that you can go and check the top threats like XSS, SQL injection, CSRF injection, insecure deserialization, security misconfiguration, broken authentication, sensitive data exposure, using components with known vulnerabilities. Components with known vulnerabilities, and insufficient logging and monitoring. You can see that you have the chart here, that you can go and create your short notes as per the exam perspective. First 4 or 5 will be the target for this particular subsection. All right, so I hope that you understood that this is very much like theoretical session we have. This is just for our understanding that in applications also injections and forgery can happen. And If such type of things are happening, we should have plan. Actually, plans are there. We know the impact, we know the threat, we know the impact, and mitigation plans are also there. Someone has to use the process, someone has to go and know that this can happen, and according to that they can build the plan, and it should be applied in the proper manner, right? All right, so let's stop here. Let's start 4.11, where we have to understand about bash command, file management, directory navigation, and environment variables. So what I have done here, that I will explain you these commands. It's easy, straightforward. You need to go and run this, practice this in your Linux environment. And then what I have done, that because this topic is important, I have added few videos so you can see that, understand the Linux file system, the Linux distribution and packet manager, working with files and directory, part 1 and part 2, file permissions, and Linux process, like that. I have added 1, 2, 3, 4, 5, 6 videos after this video. So you can go and understand. First of all, let me go and explain you all this, but you have dedicated videos, lab videos. After this, you have six videos that you can go and watch, and you can create your own notes, you can create your own, you can perform your own lab. So starting with file management, you can see that we have a long list. LS short form for list directory content. LS minus L will give you the list directory contents. It will go and list the directory contents. This is one of the most useful command, usable command we have. CP stand for copy, MV stand for move, RM for remove, touch, that means it will go and create an empty file or update timestamp. Cat is also very important, that is concatenate and display the file content. Here you can see the examples as well. Suppose you want to copy source to destination. This is file 1 to file 2. You can use CP, source destination, move old to new name, remove the file name dot text, touch creating new file, cat see the content of file dot txt. Then we have echo command as well, that will display a line of text, echo hello world, it will display hello world. Then you can go and create some new files. You can use VI editor or nano or gedit, that is the editors. You can go and create new file and you can write content in that. Then you can change the permission with change mode and change the owner and the group. So you can use these commands, that you can go and change the file permission, change the owner and the group. Again, in the upcoming videos, we have the lab related to this that you can go and check. Next in the line, we have the directory navigating commands. PWD, print the working directory. Then CD, change the directory. Make directory, remove the directory. List directory contents, ls minus la. Find, search for files, find path name, file name. Du disk usage, estimate the disk usage, so you can understand the usage of the disk. Apart from that, the next thing here in the line is that environmental variables. The command for that is print the environment variable, echo the variable, export, set the variable, unset the variable, and the environment. Here you can see that example usage: print env, echo home, export the variable name equal to value, set some variable, unset the variable, and environment env. Run a command which modified the environment variable, that is short is env. You can go and use the env variable name, value, and the command. Okay, so these are the examples we have, right? These are the examples we have. After that, you can go and watch these videos. Most of the things are covered, and I have added some more commands as well that is not in the exam curriculum, but you will get some more information, and that will be helpful, useful for your normal day-to-day activity. Okay, so after that, you please go and watch these 6 videos, and we are completing section 4.11. So the first basic topic we have is to navigating the Linux file system. Now in the Linux operating system, everything will go and start with this forward slash. That is nothing but the root of the directory, that is the parent one. And then beneath that, you can see all the other file structure. So if I go and log in, let me quickly show you this. And in our lab, we have two operating system. So let me quickly show you, say etc and then OS release. So here we have Ubuntu, and then when I do the SSH, that is nothing but the CentOS. So both the operating system we can go and verify. So first of all, if you go and check who is your present working directory, here you can see that forward slash and root. Now, if I go and check what are the possibilities I have, say for example, here you can see the file structure related to Ubuntu. So I have etc, library, opt, sbin, temp, bin. One folder is GNS3, library 64, proc, script, user, boot. Means these are the structure for the file. And suppose, for example, if I want to see the network setting, then what I can do? I can simply go and check, say for example, etc and network and then the interfaces. So here you can see that this is my network setting. At the moment, my DHCP is enabled, so that's why I have this type of setting. Again, we'll learn more about this cat command and other command that we can go and use in upcoming session. But everything will start with this forward slash, and then you have complete file structure like this. So once you are inside the root, then you can go to any individual folder, and then you can go and check the files related to that. Correct? Now since everything is just starting with this slash, you can go and use su as a sudo su. Sudo is nothing but a super user. So this is that for super user, if you want to change the password. So let me show you that as well, little quick what I try to explain here. So what I can do here, that I can go and use, say for example, sudo su, and here you can see this command is not there in this particular version of the Ubuntu. So what I'll do, I'll quickly go and do the SSH for my CentOS, and once inside the CentOS, then I can go and check the present working directory. So this is with the home, and now I can go and use, say for example, sudo super user. Now it is asking the password, so I am giving the password, and seems that I don't have the access. Yep, so password is working. Now if I go and check the working directory, here you can see that the home, we are inside the home, but yeah, I have a privilege here that I can run the command related to super user. So in that case, if you want to run certain command, that command don't have access with the normal user account, so you can go and use, say sudo, and then you can go and run the command, say for example etc and os release, like that. So now you have run the command as a super user sudo, correct? So that's one important basic thing we have, that suppose if you're working somewhere, you're doing some upgrade or something and you don't have access, you can try that, do you have the sudo user access? Now we have basic commands like present working directory or print working directory. So in which directory we are, it will tell you this with pwd. Then we have ls command, that is the list of the working directory, and it's a very important and basic command whenever we are doing any Linux related work we used to do. And I will go and show you various options related to ls. Then we can go and check this manual, say man page or help page we can use to know much more about those commands. So for example, if I'm here and Suppose if I don't know about ls, so I can go and open the manual page for the ls, and here you can see that what options or plugins I have. So let me go out once so I can show you step by step. So here you can see that list information about the files, the current directory by default, sort entries alphabetically if none of these nor sort is specified. Okay, so you can see that how many options you have related to plugin, and again you can go and check, say minus a stand for all, minus capital A almost all, does not list dot and double dot, then the author, then what is meaning of C, then D, G, H. If I scroll up, you can see that I have H as well, and likewise you can go and check the command related to ls, correct? All right, so if I can go here, ls minus la, long list of everything, or if I do ls minus a, means all, so it will go and collect dot and double dots as well. And if I go and use ls minus capital A, it will exclude dot and double dot. Apart from that, it will tell you everything. So we can go and use ls minus la, and this will tell us the users group and the file size and much more information about that we can see in the upcoming slides. So we can go and check the configuration or the manual page related to ls, and again here you can see that same thing I have taken from the manual page that we have seen just now. What we can do, that we can go and check the print working directory, and then we can go and go inside any of the directories. So that cd command is there, that is to change the directory, cd. And now when we are working with cd, change directory, so at that time remember that we have two different type of path. One is absolute. What does it mean by absolute? Absolute means that this is related to or related to root directory. Root directory is what? Is forward slash. And then other one is the relative, that relative to that related to that particular present working directory, or that particular working directory. So anything belongs to root, that will be the absolute, and present working directory related folders are relative path. Okay, so what I will do here, that I will show you the lab, a small lab or a small task related to cd, that is the change directory. And as I am doing, you can also do the same thing. So once we'll go and create certain folders, we'll move around the folders, or we'll move around the directories, and then we can go and use cd double dot. That means it will come one folder or directory back, then cd directly come to the home directory. We can nest the cd like this, dot dot forward slash dot dot, and then we can go and use cd hyphen as well, correct? So let's do this lab, and then we will stop. So what I can do here, I can go here, and even I can exit from here. I can show you this in our, so you can see I have to exit twice because I was there as a super user inside the root directory ideally, and then I exit, and then again I exit. Now I am inside the automation. So what I can do here, I can go and create, say, some folder, and later we'll learn about this option, that make directory will create the directory. So I can go inside one, then I'll go and create, say, 2, then I can go inside 2, then I'll go and create 3, I can go inside 3, then I can go create, say, 4, I can go inside 4. So you can see that I'm inside 1/2/3/4, and what is my present working directory. So here you can see print working directory or present working directory, root, and then 1 2 3 4. So if I do cd dot dot, I'll come one step back. If I do cd dot dot slash dot dot, I'll come 2 steps back. And if I do cd simply, then I can go to the home, correct? Again, I can go to cd1. So let me do 1, and then 2, then 3, then 4. Not like this, but we can go like this. Okay, so you can see the difference, that you can go like this because already we are in the root. And now if you do cd and hyphen, you can see this is not there, but so directly we came to root. And again, if I go to here and if I do cd, and then I can type pwd, so you can see the differences. Okay, all right. So this is the basics that we can log into the Linux system and do some basics commands related to Linux. Now we are ready to understand Linux distribution and package management. And here you can see clearly that we have two main releases of Linux, or two main Linux version. One is Debian and one is Red Hat. Although we have more than 300 flavor, or you can say the instance of Linux operating system, different coders, different company, different group of people, they have created their own version. But out of them, the most popular one and stable one are Debian and Red Hat Linux. Now again, you can see that the latest stable release inside the Debian is Jesse. Here you can see in this slide, point number 2. And then the Ubuntu is also quite popular. So you can see that we are using the network automation tool based on Ubuntu operating system. And then when it is coming to Red Hat uh, Enterprise Linux, that is actually for mostly for the commercial purpose. Apart from that, training services and support. Now the inside the Red Hat Linux, you can see that the main versions are Fedora and CentOS, and that's why we are using CentOS as well in this lab. So we have both the flavors. One is the Ubuntu and one is the CentOS, so we can cover most of the commands related to these flavors. Now here you can see the important note that different Linux version or different operating systems inside Linux, they have their goal. So for example, the Kali Linux is focused on penetration testing and security testing, while OpenWRT is focused on home router functionality. Likewise, the CentOS that we are using in our lab is the stable one, and Fedora is considered less stable, but it is a testing ground for new features. So Fedora is used for testing purposes. Okay, so we have two flavor, one is the Red Hat and one is the Debian. And then how we are going to update, install, or do the say for example package management inside these operating system. So let's see one by one. So first of all, let's discuss the package management. What does it mean by package management? So package management is nothing but a way by which you can install, upgrade, configure, and remove software from the computer. And previous to previous video, you have seen that we went there and we have installed the Python. So we have do some upgrade, and then we have installed the Python, NetMiko, and PIP. That is one of the example related to uh, Ubuntu. That is uh, the umbrella for that is Debian. So inside Debian we have Ubuntu that we have seen. But how we can do the package management inside Red Hat? So for that we have this RPM, Red Hat Package Management. We can go and use that command. We have yum, yum, download and install the package from repositories, and WRPM is just a file extension for the RPM files. So how we can do that? So for example, if you want to install the traceroute You can go and use sudo yum install and the trace route. So let me quickly show you this. I can go to my CentOS. So let me do the SSH to the CentOS. Seems that I have to do the SSH, and let me see the IP. So this is the IP we are using. We are inside the CentOS, and then what I can do, I can go and use the command say sudo, that's just, the super user, and then I can do yum install trace route. Now again it is asking the password for the sudo. I can go and give that. So let me do that. And then here you can see that it is updating this. So you can see that we are using the yum functionality that will go and download that from the repository. Total download this much, and you want to do this, yes. And now you can see that traceroute is installed. This is the traceroute package that got installed inside the uh, Ansible. We have actually the CentOS. So here you can see that the RPM file is this .rpm. This is the package, and it got installed inside the CentOS. So once it got installed, I can do the trace route. Say for example, 122.29. I have 29. I can go and check the hops. So how it is, and then you can see that how it is going multiple hops and reaching to this particular IP, correct? All right. Now, what about the Debian family? Debian family we have already discussed. We have done this lab actually in the previous section while we have upgraded the Python. So in that we have the package that is D package or the Debian package .deb, this is the package extension. Then what about the application installation? So for that we can go and do the apt and apt-get, and then it will get installed, and .deb is the file extension. So let's do the installation of traceroute with inside the Debian, and that's we have our Ubuntu inside the network automation. So I can go and do the sudo. All the sudo is not required, so simply I can go and do apt-get install trace route, and now here you can see that it is installing the trace route. Here you can see now there are some miss, maybe it is already installed. So here you can see that it is telling that because associated file or link doesn't exist. So what I can do here, let me use this trace route for Google DNS, and yes, already trace route function is there in this system. Now you can see that how it is going. Okay, so that was the main agenda for this particular session, that we should understand various distribution and the package management and the package management commands, and we went there and we ran that command and we have done the installation as well. Now here you can see the summary for the apt-get. Later on in the Python section we'll learn about the file and directory, so we'll do the other labs as well. All right, so let's stop here. This is important and a little bit lengthy session. So what I have done, that I have break this session into two recording. Let's start and understand that what is the principle, working principle for file and directories. And this is something that we have to do day to day. If we are logging to the Linux machine and we have to check certain files, create certain directories, search something, we have to do all these operations listed here. So let's try to understand all those commands one by one. So starting with the command called touch, we can go and create the empty file. So here you can see that to create empty file, use touch command, which creates a new empty file without, so here you can see, without automatically overwriting existing file. So what we can do here, that while we are checking the commands, I can go and log into the say Linux system, and we can go and do the labs parallelly as well. So what I want here, that I want to create the file test, correct? And then I can go and check, do I have anything inside the test. If I go and check the parent directory, we are inside the root. Here I can go and check the ls-a long list, and we should have test here. So here you can see that I have test. It contains nothing, zero, and then the permissions we'll discuss later on. But yeah, we are able to create a file with the command touch. All right, this is not the only command that we can do it. We have other commands as well that we'll go and check. The other command that we have is the make directory. So here you can see that mkdir is the other command that we can go and create the directory. So let me go and create the directory with the make directory, and let me show you that as well. So here we are, and I can go and create, say, mkdir. Already we have seen this earlier. So make directory 1, and it's already there. Here you can see that I have the directory whose color is blue, and say I can do this just to show 1z, and say ls minus la 1. So here you can see that we have 1, we have 1a, we have 1z. So all files created here, all files that is starting with 1, actually these are the directories. So let me show you this. Now in this list you can see that 1a and 1z, because D is written here. D stands for directory. So these are the directory. Inside that I can go, I can change directory, I can go here, and then I can go and create, say, 1.txt. So I'm using nano file. That's a standard that we can go and use. Now once I am here, I can put any text. I have just put 11111. I can type Control O, enter to save, and then Control Z to come outside. Correct? So we have various editors. Actually, one of the best editor and that I like, and in future you will see that I'm going to do all the Python lab inside the Nano. You can use this, although we have the VI editor as well. So VI editor also I can go and use. Here also I can use it. You have to press I to insert, and then again you have to press escape, and then oops, shift and Q and W, that you are quitting and writing. So let me come out from here, and yeah, so say different version has some minor changes. So I can go here now inside 1a, and I can see that what is there, what is the content. Likewise, I have created one other file as well. So let me quickly see here that what are the files I have. And if you want to see this in the human readable format, so you can use ls minus lh, and you can see this um, bytes and kilobytes, etc. So I have created one.txt, I have created one a.txt, I have used vi editor, I have used nano editor, and I can go and create files if you want to see this. Then we have multiple options to view these configurations, and in that, let me show you first that what options we have to view. Then I'll come back and I'll show you this make directory and some other options as well. So let me go next. So here you can see that if you want to view the file, you have more, less, cat and head. All the time I'm using this cat command so far, but we'll go and test the other commands as well. Now, since I'm using cat, what this is doing is that stream the file top to bottom without pausing. And that's why it is showing all the content in a single shot. So we have option with make directory minus p. That means it will go and create any of the directory inside the subdirectory as well. That is basically not possible in normal case. So what it is telling here is that suppose you have to create a directory called 5. So what you can do here, you can go to cd 2, 3, 4, and now you don't have anything and you want to create 5 as well. So you can go and use a mkdir without p. You can go and create that, and here you can see that if you use the p option, makes all required subdirectory in the path. So I can check this in the CentOS as well. But for example, if you execute the command, all the directories between your present working directory and Nexus uh, have not been previously created, the command will execute and create all the directories in between. Okay, so let's test this. Now, if I do make directory like that, it is obviously creating directory file this 5 as well. So now I can go to say 2 and then 3 and 4, and then I can check ls minus la, and here you can see that we have the 5 as well. So let's try to verify one more time. I can go back here. I can use say mkdir a b c d e f. Now here you can see that it is throwing an error, but if I can go like this and if I use minus p, you can see it is creating this. So now I can go to a b c d e, and I can go and check, and then I can check the f as well. So this is the use case with make directory minus p. It will go and create all the directories in between the path. Then suppose if you want to remove, you can go and use rm, remove the file, rm minus r, remove an entire directory, remove the directory, removes an entire empty directory as well, rm minus rf, etc. So let's quickly verify this also. I can go here inside, we are inside E. I'll go and create one of the file, say nano 1.txt. I'll put this, I can go and come out. We can go and check. So this is the file, then I'll go and create say touch2.txt, and then we can verify. So I have 1.txt, 2.txt. Now remove one, okay, and remove say You can see that with the remove command, I can go and remove that. Now, if you want to remove the directory, you can go and use the rm-r, and that can be interesting. So what I can do here, that I'll go back, create these files one more time, and just we can give anything here. I can come back, I can go one step back, and then rmd, because it is the directory, it's not a file. So what I have to do, that I have to go here, and then I have to use this rm-r. See, removes an entire directory and its content. So rm-r, and I should remove the directory. So what are the directories I have inside this? Let me quickly see here. So I can see this directory E here. So I can use remove -re, and then you can see it's gone. Correct? So this is the way that we can go and use the RM, and you can see RM dir and RM RF as well. Likewise, we can use. Now the next very important command we have is the copy command, and we are going to use a lot about this copy command. So when we are using the copy command, copy, source and destination we should give. So I will do, and I'll show this copy as well. So we have two commands here in the list, copy and move, CP and MB, and both of things we are going to see here one by one. So let's verify the CP command and the MB command. Now here you can see one thing very important is that the command that we are using is actually very small but very powerful. So only rm will remove the directory, mkdir will create the directory, you can create the file, you can create the file, inside that you can put the text, you can save it. So everything is easy once we learn the way that how we can do it. Okay, so let me go and create some of the file. Already we have one.py, so I can go and check what is there in one.py. Is a Python file, and seems there is nothing inside that. Then login.py, here you can see that the information related to logging, this is actually one of the Python small script. But yeah, I have this login.py. What I can do, I can copy this login.py to login, say CentOS.py, and then I can go and check cat login CentPy. So here you can see that how easy to copy the commands or copy the configuration. Then I can go and use move, and then say CentOS to new.py, and then I can go and use say cat new py. So here you can see the use of move. So use of move command and use of uh, copy command, correct? So we can go and check the login, and then let me see. So here you can see that my file has been moved to new location, that is the py, correct? So now it is telling that you don't have the login dot this py file because already you have moved this file. So you can understand the use case for CP. CP will copy, it will retain the file, and then it will paste the new copy at other locations, so you have two files. But move will simply go and move the file. Okay, so these are actually very important command, and while we are doing the study, or while we are doing the testing inside the lab, we should go and use all these commands Although in future you will not use all these commands, but it's good to know most of the options that we have related to configuration. Okay, so finally here you can see that we have the other options here. Other options means how we can read the files. We can go and use the more command, less command, cat we have used a lot, head command, tail command. So here you can see there's tail command and diff command. So let's stop here, and next section will start from here. Let's continue where we left off. So we have some important command to view the file. So for example, more, that we can use and check the output, and then we can press a space to go page by page. Less, where we can use the up and down arrows to scroll through. Then we have the cat command. It will give you all the output at a time. You can think cat command is something like when we are typing terminal length 0 in a router, and then we are running any output like show, run, etc. Head command, that will give you the first 10 line, that's the head. And if it is a tail, that means it will give you last 10 in the file. Diff will show you the difference between the two files. Okay, so there is some explanation regarding to more, less, cat. So what I will do here, that I'll go quickly, and first of all I'll show you the output related to all these commands one by one. So here I have my Ansible server, which is hosted over CentOS. And if I can go here and check what files I have. So I have one file called main.yml, some program in YAML code. I can go and type, say, more, and then main.yml. There you can see, while using the more command. So since this is it actually, this is the full configuration here. Let me do one thing. I'll go here and do the manual, say for example for ls, and then I can copy this output that we are seeing here. So let me create my own file so I can show you the differences. So let me quickly go here. Let me create my own file while copying all these outputs that is there in my screen. And this we are doing just for our testing purpose. So for example, from here I can go and copy all this configuration till here. It's copied. I will go out from here. I will create my own, say, test file. I'll go and put all those configuration that we have inside this. I can go out from here. Now I can go and check the more command. So more with test, and here you can see. Now I have to press a space to go out. Now I can go and use less as well with the test file that we have, and here I can use my arrows. So here you can see that I can go up and down. So much more flexibility we have, that we can do up and down. Okay, so let's go outside from here. Then we have other as well. Say if I want to have the output like all the output at a time, and then I can use my putty terminal up and down the scroll bar to go up and down. Then we have the head command. So head and test. So here you can see that you have uh, first 10 commands, and then I can go and use tail and then test. So here you can see the last 10 commands. Okay. Now the important thing here is where we are, and that's actually quite important. We are inside this particular folder. I'll go to main folder, and present working directory is this. Still, I can use the cat command. I can go to this directory, and then I can go and run test. I can check the test. And that's the power of the Linux. We have that we can scroll through, we can go through number of folders, number of directories, and then we can reach to that particular place. Not only that, we can go and do this thing, but you can see here that I can copy as well from this folder. So for example, copy, and then you can paste here test. And now if I do ls minus la, so here you can see that we have the test from this folder to this folder, correct? Now again, if you want your test output to be stored in, say for example, test 3, and now you can go and check test 3. So here you can see that means your new file test 3 has been created. So let me quickly show you these things in the slide. So here you can see that you can go and go inside folder inside multiple folders, and you can check what is there inside that. You can have the copy like that we have done with this double greater than sign, and then you can create router 2, and you have new output in router1.txt. The last command we have is the diff command. So what diff or the difference command will do, suppose if we have two files, say file 1 and file 2, and if there is any difference in the configuration, so that diff will tell us. So what we can do here, that we can go back to the CentOS, and here you can see that we have test 1 and test 3, test and test 3. So for test 3, we can go and add the difference. So I'll go here. We have this many big file which is almost similar. I'll go and add here. This is the difference, correct? So this is the diff, etc. All right, and now we can save it, and then we can run the diff command to see the result. So let's save this, go outside, and then we'll run the diff command. Say diff test and test 3, correct? See, it is telling us that this line only having the difference. Even we can go and use diff and u as a user, and then we can see the difference should give you access to the complete manual. This is the difference. All right, so these are actually very important and uh, very fundamental basic command we have, that whatever we have covered so far in the Linux series of the say videos, and we are going to continue this. Again, we have to learn more about the basic things, and then we have to learn about the Linux networking as well. In this important section, we have to learn about the file permission and the Linux process. So let's start this file permission and the Linux process. Now we know that we may have multiple users, and then we required actually multiple permissions as well. Multiple permissions like read, write, and execute. Okay, so for that reason, in Linux, it's actually very uh, enhanced, you can say. It's very advanced as well, that you will not find such type of file permission and types of file permission, and the uh, ease or the way that we are doing it or achieving this target. It's very easy and fast, and it's very small type of commands that we have to run to change the permission, or to give the permission, or to give the right access or the other access. So what type of users we have, we should understand first of all, and then what type of permission that we are providing, that is also very important. So here you can see that we have a user, that is owner, group and other, and then the permission we have read, write and execute, correct? Now what type of file type we have? So file type is D. Here you can see that D stands for directory, and let me quickly highlight so you can see that we have the file type D here. Now suppose if someone has less access, less privilege, because we have three: read, write and then execute, then how we can change the mode? So for that we have this chmod, change mode option, and then u, that is my current user or the admin. So u plus x means that we are giving this current user execute permission for this particular file. Likewise, you can go and give the permission to the group and others. So G stand for group and O actually stand for users, or we can say others as well. So we can give the permission for group and others or users as well. Here you can see this is the important one. This is the summary. So you can go and use chmod command with the current user or the admin or the group owner. Then we have the group, and then we have the other, and then we have the read, write and execute permission. So let me show you this, and then it will be very much clear. If we go and execute this permission over the Linux machine, so let me go and log in here. We're already inside the CentOS, and I'll go and create one file. So let me create one file, say 44.txt, and then let's go out from here. Cat 44 will see this content in the file, and then what we can do here, that we can check the permission for this 44 file. Here you can see that for the owner, that's the current user or admin, then the group and then the other. So first two users, they have read, write access. So let me change the permission for the admin. So I can go and use change mode, and then I can use u for the admin or the current user, and then execute, and then 44.txt. Now if I go back and check ls, you can see that this user has execute permission. So rw, and then initially x was not there, now it is showing here. Now the same thing if you want to do with the other users, so what we can do, again we can go to the change mode, and then I can go and use geo. These are the two. This is the group and this O is other. So these two sections we are selecting with geo, and even I can go and delete this U, because already we have given permission to U. So geo plus x 44, and then if you go and check ls minus la, so here you can see even the last user don't have the right permission because we haven't given it. So I can go and use only that permission, that means O plus right. Even we can use minus as well. So let me show you this minus as well. So for example, with this user, I just want to remove the execute option, and then you can go and see that's gone. Okay, so you can see how easy just one small command, and then we can add or remove the permission from different type of users. All right, let's continue. Then we have this summary slide here. Just for your reference, you can go and have a look with all the uh, groups or all the collection of groups where you want to give the permission, from where you want to remove the permission. Minus means you are removing the permission, plus means you are giving the permission. Okay, then the next topic we have is the Linux process. This is also very important. So we should understand that at what particular point of time, which process is peaking high. So for that we have top, htop, ps command. Top will display the real-time process utilization. H means human readable format. Some of the versions are not supporting H. PS is the current process. PS stand for process, so current active process. Then one of the nice thing we have is the PS aux. Now this PS aux is that will display the exhaustive list of process by all the user, and that's quite important command we have. So one command is important, that is top, and then this PS aux command. We'll run these commands and I'll show you as well, even if you want to do some sort of filter with these commands. Even with any of the commands, we can go and we can do pipe and we can grep, we can search, and then the Linux will give that output only, that is specific output only. So for example, if the Firefox is speaking high process cycle, you can grep the Firefox and then it will show you that what is the process utilization with the Firefox. So let me show you up to this point of time all the commands. So for example, first command was top. So here you can see all the CPU, memory, and all these process and cycles. Then I type Control Z, I'll come out. Then we have the PS. Now PS, you can see it's not showing you the full process utilization with all the users. So we can use aux, and then you can see all the users and the process utilization. So what I will do here in the back, that I will go and do the ping to this system from one of the remote system. So for example, and I'm doing the ping, and let's see if I'm catching the ping here. Oops. So let me go back, PS aux. So here you can see that ping is going on, and that process is 1978. Correct. So we have checked the top, we have checked the PS7. Htop is also there. Some of the versions will not support this htop command, like it is not supporting, but it's okay. Then finally, suppose if you want to filter anything from the PS, so we can go and use the grep command. Say for example, grep, and I want to see Ansible users. So here you can see that it is showing you the process with all the Ansible user. Inside that you have this ping, and some SSH is also there, because I only have done the SSH to this particular system. Now suppose if I want to stop the process, so for that we have the command called kill. So here you can see that I can go and kill the process that is going on. Kill has certain strings as well. So what is strings that kill has? A kill means we can go kill, and then I can give the process ID. Let us continue our kill session. So here you can see that we can go and kill anything, and these are the users I have. Let me go and show you the process, the PS aux. Now in this I have one ping that is continuously going on. So let me show you that ping as well, that is going on continuously. And what I want here, suppose if I want to kill this ping process, first of all I should know the PID or process ID. So process ID is 1978. So what I can do here, I can go and kill and this process. Once I do the kill, here you can see the ping has been stopped. Correct. So means that process has been terminated or has been stopped. Now again, here you can see that we have other strings as well. So for example, kill -9 will force the instance of a process to be killed. Kill -L will give you the list. Kill all, it will go and kill all the instances related to that particular process. So for example, in Firefox, you have opened 10 different websites. So all these websites, they have their own individual ID. Each and everything will be killed if we go and kill Firefox. Means all the web browsing sessions will get killed. And then finally, we have the pkill that will send a signal to end the process by the name. All right, so these are the kill process that we have. Let's just stop here, and in the next session, we'll start Linux networking. Good job. So we have completed almost everything in section 4. The last video, that last subsection that we have is the principles of DevOps. Okay, so let's understand the principle of DevOps practice, because it is important to understand the principle of DevOps practice. And good news about this is already we know all those terms. So if you follow my videos in section 1, section 2, section 3, and remaining in section 4, remaining video, then the principles that we are going to discuss now, we have discussed a lot about those principles and the use cases. So let's start. Let me go and give you the list of principles. We have total 11 principles, and starting with the collaboration and communication. Yes, the development team and operation team should collaborate, and they know the restrictions and they know the requirement of each other. So the development team should know the operational requirement, and operational team should go and provide such type of requirements and restrictions to the development team. So they have the shared goal. So they can reach to certain point. Obviously, these teams, they have the shared goals and the responsibility. So collaboration is very important. If they are doing the collaboration, the management layer or the director layer should provide the collaboration and communication in between different teams. That is one of the hurdle you will find in the big enterprises, because generally these teams are communicating well within themselves. But suppose if these teams has to go and communicate to other teams, uh, there are problem, because those teams, they are very good in their areas, their domain. So networking team knows network very well, automation team knows automation and development very well. So if we have some common interest, like if someone knows network and automation, can do the communication in between them. It's something like that. If you have some common uh, common guy, if you have some common engineers, in terms of that they have knowledge of IT and the network and the automation, so they can become a bridge. They can go and fill the gap in between the different teams, or in between development and operation team. So that is one of the very important point we have. Then automation. Automation means that provide automation. That means whatever repetitive task we have related to testing, deployment, and infrastructure provisioning, that can be automated. Utilizing the CI/CD pipeline, we have discussed a lot in our previous section about CI/CD pipeline to streamline processes and reduce manual intervention. So if we have automation for the processes, if we have automation for tasks related to testing, deployment, and infra provisioning, then obviously the chance of error will be less and the time will automatically get reduced. Accuracy will be more and time will get reduced. Then you can see that use the best principles related to CI/CD pipeline. So use that CI/CD pipeline, continuous integration, continuous deployment delivery. Obviously, continuous feedback is also one of the things that you will see in the next section. So here you can see that monitoring and logging, continuous feedback. So these points are already there. Why? Because we know This should be the principle, right? This should be principle that different teams should go and communicate. They should do the automation, and they should create some test cases uh, to to check their scripts, to check their module approach. Means obviously no one will go and develop the entire solution. So the solution that automation team, the solution that we have with the automation, it should be testify phase by phase by phase, right? Then continuous integration, and we have continuous deployment delivery, infrastructure as a code. The team should go and use Terraform and Ansible and CloudFormation type of programming languages to provide the infra as a code, manage the infrastructure through code. This is one of the goal for which we have the CCNA, CCNP and CCI level of DevNet that can provide, so engineer can provide infra as a code. That's the goal for big enterprise nowadays. Constant monitoring and logging and continuously getting the feedback to improve the program. So after development, if you go and use that product in the production, that automation script or the software in the production, then we should have loop for continuous monitoring, logging and feedback so it can be improved. Next, you can see security is also very, very important part. Do not use vulnerable code. Do not expose your APIs, use safe APIs, like that. Security part we have discussed. We have discussed in our previous sections related to security and what type of vulnerabilities and what type of attacks in terms of doing some injections and forgery, etc. So we have discussed about that. But yeah, use the principles related to DevSecOps, DevNet security ops, that will provide the security. Version control is also very important. That this also we have discussed in our Git section, GitHub section, that versioning control that will track the changes to the code, configuration and infra, and this collaboration will enable the rollback capabilities and audit trails. Then about the agile methodologies, we have discussed about agile methodology as well, where you have different type of methods like sprint, scrum, iterative development. That you should not go monolithic. You should have some incremental improvement, incremental development, incremental feedback loops, monitoring, logging, etc. So the program, the software should be developed, should be, you can say, sanitized, should be you can say the stability in the product. So all those things will be there, and it should be fast. So for something is coming, you will not wait for other processes to do, other development to do. So suppose if you are doing a step number 1, 2, 3, 4, and you have to do a step number 5, so you will not go and check 1, 2, 3, 4 again and go for 5 and 6. Like, your approach should be incremental. For something, you should not wait for something. It's like that. And finally, culture of learning and experiment. This is also very important. This is very much related to manpower workforce that we have, that they should go learn and do the experiments, promote blameless postmortems and iterative improvements and process. Now, I can discuss on this for more than 20-25 minutes, but just to make this short, that we should provide the IT engineers some sort of what you can do, shielding as well. So if someone miss something or do some misconfiguration or mess up something, we should protect them as well. That means that ready for the risk, you know. So as an organization, as a management and director level, they can they can take some risk as well, so they can protect their employees. Finally, customer-centric approach. That is also very important. Whatever product that as a company I am developing, obviously that is for the customer, that is for customer user experience and all. So our product should prioritize customer needs and feedback, align development and operation effort with delivering value to end user. Right. So these are the principles related to DevOps. And actually, this is something that we are using in normal day-to-day activity as well, minus the automation. But normal routers and switches, we are doing security. For some project, we are using agile methodologies. The engineers, IT engineers, they are getting knowledge upgrade all the time, new courses, new packages. We are very much customer focused. All the businesses are customer focused if they have to win, if they have to sustain. Continuous feedback and monitoring is there, different tools are there, collaboration. Yeah, this is some area that management can work on that, and people are trying to do automation as well. If you are doing automation, then this CI/CD will come into the picture. All right, so these are the principles related to DevOps.